Hello. Welcome to the second day of the LEGO build for Space Shuttle Discovery. Let me pull out the box yet again for this second day. I hope you can see that. Maybe I should go onto the screen here. So yesterday, if you didn't catch the stream or if you hadn't seen yet, we built LEGO Hubble. It took us about 2.5 to 3 hours to work on Hubble. Is right here. Built this sign, the bigger sign for the space shuttle. Hubble. Oh, try not to get the glare there. And we also built a space telescope. Pretty fun. See the lens inside and the solar arrays. The sides here, and today we're going to be getting started with the main frame of the Space Shuttle Discovery. Here's also the base. Yes, I should have shown that as well. So we got through about 70 pages of the instructions yesterday, and now we're going to be starting from page 70. Starting with book number 5. Hello, Abu Abarkar. I don't know if I pronounced that correctly, but looking so interesting and wonderful. Yeah, it should be exciting. It should be a fun build today. We might get more of the frame done, some of the base of the space shuttle. I hope you can hear me well, if I'm not muted or anything. Turn up a little bit. Perfect. So bag number 5. Let me just sort all these pieces to make it easier for us to find the colors that we need. Starting to get into the bigger pieces now, so hopefully that means some of this will come together pretty quickly. These smaller pieces, a smaller bag there. Even smaller bag. How many miles away is Hubble from Earth? A great question. So it actually tells us on this little sign that LEGO has here. I don't know how well you can see that. But here it says it's a 350-mile altitude. And actually, in the beginning of the book here, It says what that is in kilometers. Let me pull that up really quick. So 550 kilometers or 350 miles. And that gradually is getting closer. So the Hubble Space Telescope is in a low Earth orbit, pretty close to Earth. It does experience quite a bit of atmospheric drag, which gradually brings it down back to closer to our atmosphere. But yeah, so the Hubble Space Telescope is, in terms of observations, is pretty close. Pretty close. Not like the moon or Mars or anything far like that. That just goes to show, the Hubble Space Telescope is in low Earth orbit, and over the last 30 years of operations, or after some of the servicing missions especially, we've been able to get so much excellent data from Hubble, and we've gotten so much insights from Hubble. So it just goes to show that, really just getting out of our atmosphere is all that needs to happen in order to really improve some astronomy observations and our ability to look further into the unknown or into the universe or our past, I guess, which is pretty interesting. We don't have to travel that far out of our atmosphere to get some pretty excellent results in terms of visible observations. Right now we're adding these yellow things. I'm not quite sure what they are or what they're going to be. I imagine it's probably going to connect to maybe the engines at the end. But we'll just have to wait and see. But yes, again, according to this little sign, Hubble was launched in April of 1990. So it's been up there for over 30 years now. It has had multiple servicing missions, so although Space Shuttle Discovery initially sent it up there have been a total of 5 missions on the Space Shuttle to go and service Hubble. And each one of these missions has led to a wide range of essentially either improvements that need to be fixed, errors in the original hardware, whether it was the first mirrors, updating some of the computers on board. Each one of these had a different approach to what needed to happen. So yeah, it's pretty exciting. Hubble has been able to do quite a bit and has been able to be successful with a lot of the help from these servicing missions. We can go into a little bit more detail on those for a little bit. Hello, Andy. It says, how far, honestly, with everything in private and government sectors taken into consideration, do you think we are from landing a human on Mars? That is an excellent question. I talked about this for a little bit yesterday when I was building the first part of this set. But if we look back to the Apollo program, the first moon landings, really NASA as an entity, NASA focused on a wide range of disciplines. And even today, NASA focuses on a very wide range of disciplines, having many centers that focus on everything from aviation, Mars missions like the Jet Propulsion Laboratory, Perseverance, Spirit and Opportunity missions, the Curiosity mission, all that coming from JPL, Goddard Space Flight Center, which focuses a lot on heliosciences, astrophysics, Johnson Space Center focusing on crewed missions. All these different centers focus on different aspects of not only space exploration but also aviation. And when we look back to the Apollo era, a lot of these groups kind of were collaborating. There was there was a lot of questions regarding, how do we land something on the moon? How do we land astronauts on the moon? How do we land anything on the moon? How do we get to the moon? How do we rendezvous? And these were questions, in the 60s that either had never been done before or required a lot more, analysis. So today, speaking, we get to, okay, so what all needs to happen for us to send humans to Mars? Because, the moon is our celestial neighbor. We see it in the night sky or during the day. And, there's a lot that the moon, like a lot of advantages to going to the moon. And it's simpler to go to the moon. The flight times are shorter. Well, in some cases, it's simpler. When the flight times are shorter, there's other components that we can leverage and knowledge that we know of. So to go to Mars, it's really going to be a group effort. Hello, Professor Snape and Milky Way. Hello again. Thank you guys for joining. But yeah, so this is a very long way of getting to your question. But the big point is that if we're going, I do not envision the first human trip to Mars being one entity. I don't think it'll be, SpaceX is doing excellent work with Starship, but I do not envision SpaceX by themselves sending, all the technology necessary to keep astronauts alive. They can build the vehicles and they can build a multitude of components to get people there. But I think it really will need to be a group effort, just like Apollo was, where, a wide range of not only NASA, but also the helping contractors get to where they need to be and to develop the hardware necessary to land on the moon. So with that being said, how far out are we? Uncertain. Probably with my guess, with the Artemis program probably taking a more recent priority and sending people to the moon, sending people to Mars might be into the 2030s. And again, I say that because it's going to be a collaborative effort, and I think, if NASA has claimed time and time again, if they're sending anyone to Mars, it's going to be a return trip. And I think that's a difference between some of what, SpaceX's, or I guess Elon Musk's ideas are, vision is for sending people to Mars, because, there is the capability of sending them on a one-way trip. And there is the idea that, you can build a civilization or a settlement on Mars. But, definitely from NASA's standpoint, it seems like if they're sending anyone to the red planet anytime soon, it's going to be a trip that will go there and come back and will probably take 3 years. So that will be quite a lot of effort. So yes, I would probably say not until the 2030s. But who knows? You never know what could happen. Just looking back at the last 2 or 3 years with the development of Starship and everything that's going on in Boca Chica, that by itself is pretty impressive. Although there's a lot of other technology necessary to keep people safe on Mars, there's still a lot that we can actually improve upon and learn about. So it should be interesting. But nonetheless, Artemis is definitely one of the main focuses now, and will hopefully be a main focus in the near future. So, all right, so let's see. I saw there's been a couple more comments. Hello, Love Gupta. Andy says, yes, Artemis. Yes, Artemis is going to be very exciting. And SLS, SLS right now is probably our main way of landing on the moon. Not landing on the moon, sorry. Landing astronauts to the moon. SLS is definitely in quite a predicament. But it's important to know that, the Space Launch System, or I guess I should give a little bit of background for those that might not be familiar. The Space Launch System, or SLS, is a project, or is a rocket that NASA and a few contractors, I think Lockheed Martin, international collaboration with the European Space Agency for part of the upper stage, or the what is it called? The I can't remember the exact name of it. The I don't want to say the service module, but nonetheless, the real part about the SLS is that it's going to be sending the Orion space capsule, which is another one of NASA's space capsules, to lunar orbit. And from there, the human landing system, which was recently selected to be NASA or SpaceX's Starship, will launch, or will take astronauts from orbit around the moon to the surface of the moon, and then bring them back up to Orion to bring it back to bring them back to Earth. And the reason why that's very important, especially right now, is because although there could be some vehicles that could be improved upon and developed to send people to the moon, right now the only one that can send crew to the moon, at least hopefully in the near future after their first flight, will be the SLS. And it is a very expensive vehicle, but for at least the near future, in the next, I would say 5 years or so, will probably be the primary way that astronauts get out to near the moon. And then from there that they can land on the surface with a wide range of vehicles. So, I don't know, there's a lot from SLS. I think it has a use. Is it expensive? But it does definitely have a use for the near future. Let's see, what do James Webb Space Telescope? I don't know if it's recently been delayed. So we talked about the James Webb Space Telescope a little bit yesterday, and James Webb is the predecessor, or I guess the next space telescope that is supposed to replace Hubble. And I say replace, but it's not really going to tag team. It's more so just supposed to be the next major space telescope to provide a lot of insight into our solar system, our universe and other solar systems, and there's so much excellent stuff that's going to be coming about with the mission. However, something that's pretty important to note is the fact that it's been in development for a long time. I think the first launch was supposed to happen in the mid-2010s, and from now, it still hasn't launched yet. So, as of what I'm aware, the launch is scheduled for the end of October currently, which I think is the closest out that it's been so far. But I anticipate that it's going to stick with that launch date until some other challenge arises. But one of the main reasons why it's taken quite a bit of time is just because of the complicated nature. It has to unfold in space. Not only does it have to go to further away from where Hubble is, a much further orbit, it goes to about 1 million kilometers or 1 million miles away or so, but it also, has to unfurl safely, and everything has to be tested and make sure it runs perfectly. So not only is the launch a challenge, but the mechanisms that get there are also a challenge. So that's why it's taken a long time, is because there's a lot of tests, and there's a lot of things that if one mechanism, there's a hiccup, they had to redo it or replace it, or, there's so many components of it. I guess to keep you updated on what I'm building here, probably on the very corner of your screen it looks like we're building the landing gear for Space Shuttle Discovery. Here are the 2 wheels. And then there's these hydraulic parts, which I wonder if there's going to be a lever or something that you pull and both of them drop down. But we'll see. Alright, so let's see. Is there any mission in progress to send a spacecraft to study a black hole as close as possible? That's a really good question. So I don't believe so. And the problem is because, well, the one major problem with getting close is the fact that I don't know if there are any black holes that are that close to us. There's probably some studies on the closest black hole to Earth, but at the end of the day, they're very, very, very far away from us. Even going to another solar system, Alpha Centauri, which is about a little bit more than 4 light years away, that would take an immense amount of effort in order to send a spacecraft there. And if we do, more than likely it would have to be incredibly small, just because of how massive the galaxy is, or how massive the universe is. We say 4 light years, and probably most of you are aware, but a light year is how far it takes light to travel in a year. So light, which to us is incredibly fast, we cannot see light traversing. We just kind of see it as an instant. You turn a light on, the light turns on. It's almost instantaneous. Whereas in order for that fast of a speed to travel for 4 years, that just shows how far of a distance even our closest celestial neighbor, or our closest solar system, is to us. So if we really wanted to explore it, that would mean we would need to send something either for a very, 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 very long period of time. I think I said enough berries. Or we have to send something that's incredibly small that travels close to the speed of light. And there have been some suggestions and things that we could do. However, I don't know if any of them are coming in the near future. And even if they do, if they travel at a fraction of the speed of light, we still have to send them there and take 20, 30, 40 plus years to get there, depending on how fast we actually send them. So that's just a major component thing to keep in mind. I think I'm getting behind on a lot of questions, but so as I'm aware, no, there are no missions that are specifically supposed to go to a black hole. There probably are a lot of space telescopes that will help us learn about the formation of black holes and what happens as they form, or how they might change over time, or what happens to the variation in them. But it's also hard to study a black hole because you can't really get a lot of data out of it. It's just, it's a black hole. It takes in all the light. No information can leave it. So it's very challenging to know about it. The Ariane 5 slot, yes. Milky Way, I think it's the same thing. And then also, yes, you're stuck with the expensive SLS for a while. That's a good point. So even though Starship is definitely, a very quickly improving rocket, and there are also other vehicles that are being developed, and, Vulcan, for example, the Terran, I can't remember which letter it is, but the Relativity Space upcoming large vehicle. There's a lot of vehicles that are being developed, but the only vehicle that will be currently certified by NASA to send crew to to lunar orbit in the meantime is the Space Launch System, or is Orion. And even if Starship shows incredible success, can land on Earth and on the Moon within the next, well, I guess they've already showed they can land on Earth, but from orbit on Earth and on the Moon in the next few years or so, then I could definitely see gradually the ability to crew certify Starship, but I do not think that will happen before the first moon landing with an HLS. So, the ability to land crew from orbit on the Earth will be something that will have to be very heavily certified. And even for the case for Dragon, it took a multitude of years. So it'll be some time before that's capable. Let me see. So, do you see any future in asteroid mining? So asteroid mining is really interesting. I guess the main premise is that we mine asteroids. For those of you that might not be aware or familiar with the concept, is we go to an asteroid, whether it's a near Earth asteroid or some various location in our solar system and in the low gravity environment and with the precious materials that we won't find on Earth, we can find these asteroids that would cost trillions of dollars and get some of their resources. So I think there's a lot of technology that needs to be improved for asteroid mining. It's definitely something, in the further future where we have depots on asteroids and we decide to, have an asteroid that we want to go to and collect, whether it be potential fuel or potential metals or resources that could be useful for either processes here on Earth or for construction in space. But there are a lot of missions right now that are exploring asteroids or planned missions in the near future. I guess 2 examples is recently the Hayabusa 2 mission just got back from the asteroid Ryugu, bringing back a sample landing, I believe, in Australia. And they're probably currently looking at the samples from those asteroids. And OSIRIS-REx just left the asteroid Bennu, which also was trying to understand more about these as well. And asteroids also tell us a lot about, the formation of solar systems because they are these smaller planetesimal-like bodies. So it's always really interesting to go to an asteroid because it's like a whole new world which we never really even imaged. We can image planets, but it's very challenging to see in great detail what these small asteroids are like. So we have to learn more about them in order for asteroid mining to really become a realistic future. Where will it be put in terms of the Lagrangian point? We can use an Einstein ring sort of telescope. Oh, in terms of missions to study a black hole, I imagine you might be asking, or for the James Webb. So James Webb is going to be put in a Sun-Earth Lagrange 2 point or L2 point. So again, for those of you that might not be familiar with Lagrange points, the Sun-Earth, I guess when you're typically in orbit, for example, when you're in low Earth orbit around the Earth, you're really close to the Earth. Well, let's say, for example, you're Hubble. Hubble is incredibly close to the Earth. To put it into perspective, we said Hubble is 350 miles above Earth's surface, or 550 or so kilometers. So Hubble is very, very, very close to the Earth, and that's why it's called a low Earth orbit, because it's close. In these orbits, which is also where the International Space Station is, which I believe most Starlink satellites are, many constellations, many CubeSat missions, a vast majority of missions go into low Earth orbit. And low Earth orbit is excellent because, it's a low relay time to get back to Earth for space telescopes. It's a place where you don't need to be in the atmosphere or in very thin atmosphere, so observations are excellent. But, in terms of actual distance from Earth, low Earth orbit's very close, which is really good for orbital mechanics because, when you're really close to the Earth, your main driving force is the Earth. So you're going to orbit the Earth. The sun and the moon and the atmosphere will have a large impact on what happens. But at the end of the day, your predominant forces that are making the satellite move are is the Earth. So then what happens is, let me see what this is. Oh yes, okay. So then what happens is when you start to move further and further and further away from the Earth, so once you start getting closer and closer to the moon, for example, then you start to have the moon making a larger gravitational force, or the moon has a larger impact on your spacecraft. So when the moon has a larger impact on your spacecraft, then you kind of have the gravity of the Earth and on the moon pulling this tug of war, or maybe the sun and the Earth. If we go really far away from the Earth, maybe like a million miles or a million kilometers. The actual number doesn't really matter right now, but when we start getting further away, then the Earth will still play a pull. It'll still pull on the satellite, but then the sun will also start to pull more, relatively speaking. It'll still have a larger impact. So there's this balance between, the pulls between the sun and the Earth and which way the spacecraft, or, how the spacecraft will move around. So there are these Lagrange points, or libration points, I guess is another name for them, which is kind of in these equilibrium places, or where everything is not necessarily completely, settled, but locations kind of where the spacecraft is pulled back and forth between the Earth and the Sun. And these Lagrange points can be really useful for different missions. So, for example, the Earth-Moon L1 point, the Sun-Earth L1 point is really good for heliosciences, because what ends up happening is you're basically stuck between the Earth and the Moon, the Earth and the Sun, but you're still following the Earth in its orbit around the Sun. So you don't have to go into a different orbit around the Sun, but instead you're kind of, you're still following the Earth, or you're still orbiting close to the Earth, but you're also following that of the Sun, or you're always in between the Earth and the Sun. So on the other side, if we go to the Sun-Earth L2 point, then we have kind of like this other scenario where instead you are not in between the Earth and the Sun, but you're actually further from the Sun, or you're further from the Earth than the Sun is. Try to say it one time. It goes the Sun, then the Earth, and then your spacecraft. So here can be really useful for space-based telescopes, because you can essentially create a sun shield or block off the radiation from the Earth and the Sun, so that you only need to look out into deep space, and you don't really have to worry about the orientation of the planets or the star or the other solar system, the radiation from the Sun and the Earth, I guess, is the main point. And that's why James Webb is going to the Sun-Earth L2, is because at Sun-Earth L2, that's where, James Webb can put up their giant space shield or star shield, and it can only look out into the distance. Let me see here if I can pull up a picture of the James Webb Space Telescope. See if I can do this. I'm not sure how easy this will be. So I guess I can point out what exactly this looks like if I can pull this up really quick. What this looks like. All right, so here, I don't know if you can see that yet, but here is a picture. Here's a picture of James Webb, or what James Webb will look like. I guess you might need to let me know if you can see that. But James Webb is essentially, this is a very large satellite. I know you can't really see me right now, but the foil on the bottom is this giant sun shield. And the sun shield is about the size of a tennis court. So essentially this bottom half, I guess you could look at, the really large object, is really protecting the space telescope, which is this gold part, from the infrared light that comes from the Sun and the Earth. Therefore, they can they can focus on where they want to point this gold foil hexagon shape to really point towards what they want to look at. So these hexagons, I believe, are about the same size. One of these hexagons, I believe, is about the same size as Hubble's entire mirror. Let me double check that. Actually, not one of them, but about three or four of them combined to make up about the same size of Hubble. So you can already see that James Webb has, 4 times or 3 times the amount of area that Hubble has. So it's going to be incredible for James Webb to actually be put in this Sun-Earth L2 point, because it can use this giant sun shield to block out the infrared light from the Sun and the Earth. And it will also be able to use this massive mirror, or the collection of all these hexagons, to kind of, focus in on objects very far away from us. It can also help us explore other solar systems or stellar systems and see what exoplanets have. And also a major part of this is, they can look at exoplanets, but they might even be able to look at the atmosphere of exoplanets, helping us understand what they're made up of and if there are other exoplanets that are like Earth. Yes, Professor Snape, I did get that picture from the web. That's a really good point. So this is a major, I guess I can go ahead and remove this now. Let me see if I can do that pretty quickly. Yes, I want to remove that. Okay, awesome. So James Webb, it's going to be put in a Sun-Earth L2 point, and it'll be, it'll really be interesting. It'll be interesting to see how all that acts. And I guess I should have kept it up for one more part, but we have this giant, tennis court size sunshade. You have these giant refracting mirrors, but all of that has to be folded up into a fairing, into an Ariane 5, I believe, an Ariane 5 fairing. So that's another, I talked about this again yesterday during the stream, but I'll briefly mention it today again, is that, a lot of people usually when there's a launch coming, you're most concerned about a launch. And then when you land on Mars or the moon or something, you're also very concerned about the landing, because those are very critical components of the mission, where so many things have to go well. Well, James Webb doesn't have to land anywhere, or the James Webb Space Telescope doesn't have to land anywhere, but it does have to unfurl from its fairing. So it's almost like this very large, unfolding, origami-like structure that will spend multiple months not only getting to the Sun-Earth L2 point, but will also have to gradually open up and make its way out to where it needs to be. So not only is the launch going to be nerve-wracking for James Webb, but also the many months that come afterwards where everything will have to be basically go perfect in order to get the incredible observations. So that's part of the reason why James Webb has taken so long, is because every time they run a test and something doesn't necessarily go as planned, or there's something that needs to be improved or changed, then they try and do so, because once it's in space, nothing is going to be able to go up and fix its mirrors. There's no space shuttle that will be going to the Sun-Earth L2 point. Even for Hubble is an excellent tool for scientific discovery and space exploration and astrophysics. It's amazing. But the main problem with it is that, there were challenges with Hubble, and there were space shuttle missions that had to go resurface it. So, we cannot do that for James Webb, and, maybe we can farther into the future, but right now that is not an option. Let me see what I've missed. I know I missed quite a few of these. Hello there, Bass Nation. Thank you again for everyone showing up. I really appreciate it. The Terran 4, that's the name. That is the name. All right. You're asking about the Higgs boson. I am not quite familiar with the Higgs boson. That goes a little bit further from my understanding, to be quite honest with you. Let me see. I know I've read a little bit about the Higgs boson before. Let me see. I think that goes further into particle physics. I don't know if I can really help you with that question, but thank you for asking. I'll have to look into it and learn more. By Einstein ring telescope, do you mean gravitational lensing? Oh, there were earlier questions. Can you use Einstein ring sort of telescope? So gravitational lensing is something that is frequently, not necessarily used, but seen, and it actually kind of is used for understanding various components of, I think I forgot these. Yes, I forgot to add these fins. And is used for detecting some components of, I believe, exoplanets. I might be mistaken, but I believe that there are some cases where, if you have this large, they're called hot Jupiters, I believe. then you can actually use gravitational lensing to get mimics of stars. But that can also be the case, reverse for studying black holes. If you have an object that traverses behind the black hole, you can get an Einstein ring, or I believe they're also called Einstein crosses, where you have multiple objects essentially refracted or emitted from behind a black hole, which is also very interesting. Whoops, I already had that on there. But yeah, that's a very good question. Or a very good point, I should say. I have the Saturn V, and for the life of me, I don't know what they don't produce the tower and crawler. Oh yes, for the Lego set. Yeah, I have not built the Saturn V, but to be quite honest, I think if Lego made almost any space mission or program, or almost any spacecraft, I feel like that would be a big sell for them, because I personally love being able to recreate a lot of these things in Lego. It's awesome to see everything be put together on a smaller scale. Let's see. They kind of already used it for intergalactic objects. There are the idea of using microlensing, for example, the sun for shorter distances. I believe that's still talking about gravitational lenses. It's hard because the focal point would have to be placed like in the Kuiper belt or so. Oh, you mean gravitational lensing for leveraging the sun as your essentially as your focal point. Yeah, that could definitely be a challenge. Because you would have to be pretty far away. Why in the infrared spectrum for the James Webb Space Telescope? That's a very good question. So from what I understand, what James Webb is really interested in looking at, or it has a lot of main focuses, but one of the main ones is learning more about the very early stages of our solar system, and the formation of these galaxies. And Hubble has been able to do a really good job at looking, I believe, into visible, but maybe slightly beyond the visible range in terms of what exactly it's analyzing, in terms of the electromagnetic spectrum, or the type of light it looks at. But for infrared, for these further away objects, which are still traveling far away from us, they can get redshifted, or the Doppler effect can cause the light to change in wavelength, or essentially how it's moving relative to us can change in wavelength. So a lot of these spectrum can be shifted from visible to red or infrared. And again, we talked about this a little bit yesterday, but the main concept is that if you want to look into the infrared spectrum, then you have to make sure that you're far away from objects that emit infrared light. For example, the sun is being one. Humans emit infrared light. We have heat. We stay at our ideal temperature so that everything can operate. But it's also important to note that that the planet Earth also emits infrared light. So putting something like James Webb in a low Earth orbit would be pretty bad. And I gave the analogy yesterday. It would be like putting a telescope under a street lamp, or in the middle of a lit up stadium. Essentially, you're just drowning out by light so that you wouldn't really be able to see much. So that's part of the reason why James Webb and many other space telescopes go to the Sun-Earth Lagrange point, is because they can still be in range to communicate with us frequently, but they can be further away from the Earth, which emits these vast amount of light. So it's a really interesting engineering type of idea, using these different locations in space to help us know where exactly we want to go with. I think I actually put this on a little too early. But yeah. Boop. Now this wants to go. Yep, that wants to go right there. And let me give you a quick update on how this build is going. So it looks like we're about done with bag number 5. Here is the frame. Looks like we have the wheels sticking out of the bottom. There's the main frame. Oops, that piece was not put on well. I'm guessing this is supposed to be the thermal protection for Shuttle. That's what we're seeing on the underside here. Just the black pieces representing the thermal protection system, or all the tiles that help Shuttle from re-entering and eventually landing. Higgs boson is called the God particle. Yes, because we can see pass through clouds by infrared spectrum. Yep, that's another major point. There's not really that many people in the world. There, you know, it's a interesting point is that there's not really that many people. You know, numbers are fun. You know, 7 billion, depending on what you're talking about, can mean a lot and it can mean a little. 7 billion atoms is much less than, you know, anything we would even really notice. Whereas 7 billion people takes up most of Earth. Perfect. Now we've finished bag number 5. Going into bag number 6. The Higgs boson is a particle that's supposed to be required so that other particles have mass. Oh, that's very interesting. I'm supposed to... Yes, thank you, Steve, for mentioning that. It can also help look through nebulas. So there are some pretty incredible pictures from Hubble of, you know, various types of nebulas, or where stars are born, essentially these large gas clouds in space. And we get incredible pictures like the Horsehead Nebula, blanking on another one. Wow. I was just looking at this the other day. I can't believe I forgot a name of another one. But there's plenty of nebulas where essentially where you know the early stars form, and understanding that process of how that happens. And it can be challenging to see that in the visible spectrum. So looking through it in the infrared will hopefully hopefully allow light to peer through regions where, you know, some matter doesn't necessarily absorb the light itself, so that we can actually see what it's like through those clouds. There's a lot of really useful insight into infrared. It's kind of like, it's almost like, you know, having Hubble, which has been incredible, to now understanding more about, you know, a lot of these other questions, which we're like, okay, now we want to see this part. And that's kind of where James Webb is supposed to be leading us to. So, exciting. Oh, that's a good question, Dave. How will James Webb protect its mirror from space debris and asteroid? Unlike Hubble, it does have cover. You know, that's a really good question. I am not sure how it's supposed to protect its mirror. I don't think asteroids, because if there's an asteroid that ends up hitting James Webb, I don't know if there's anything that could really protect that. But in terms of small debris, yeah, and rocks, I don't know how much or what process it will have into try and protect the mirror itself. or even like how many impacts can actually make a difference in observation. Um, so that's a very interesting question. Let's see. All right, so next, whoops, what I wanted. Go. Okay, so yep, so we just saw that one. Is there any danger for Earth-based telescopes from Starlink? That's a very interesting question. So, for anyone that might not be aware, there's, over the last few years, SpaceX has been extending their Starlink constellation for Earth-based internet services. And a major concern, or a concern that's been brought up by the astronomy community, is the fact that, for every satellite that's in orbit, you're going to get the data that you collect could potentially overlap with the satellite. Meaning that if you're recording, over a multitude of days or weeks or months, every time that there's a satellite that passes through your field, you might have to either delete the data or remove parts of the data, which could be troublesome. And this kind of raises the question of, how can we, one, reduce the amount of light that these satellites are reflecting from the sun, and two, how much should we allow this? Should we really allow these massive constellations that could, really reduce the amount of data that is seen? And that's a really tough question. I don't know if there's really a simple answer to if it'll be a major problem or if or essentially if, with improvements in how reflective it is, it won't be as much of an issue. I think there's definitely a lot of collaboration that's needed there between not only SpaceX but also other companies like OneWeb and Project Kuiper from Amazon to be aware of how this plays an impact in astronomy or Earth-based observations. Because even though there is improvements in sending telescopes to space, and in the future we'll probably definitely be seeing more telescopes in space, that there is a very large concern with, still a vast majority of science is conducted on the ground. To get time on Hubble or some of these other space-based telescopes could be a challenge. So that's a very good question. Is there any danger? Oh yes, that was a Starlink question. Higgs boson may use concepts from quantum chromodynamics. Well, that's very cool. I'm gonna have to do a lot of reading on that. I'm not familiar with quantum chromodynamics. The M42 in Orion is one of my favorite nebulas. Let me look that up. Oh yeah, wow, that is very, very pretty. Let me share that really quick. Take me a minute. All right, I think you guys can see that. That's the one that the M42 in Orion, that Milky Way is mentioning. That is very beautiful. Yeah, it'll be really exciting to, once James Webb is up, to be able to see what is really going on in there and help us understand a lot more of some of these structures. All right, let me put that back off. Let me see. I think it should be off the screen. All right, let's keep going. The next one, Fascination Hubble had a major problem due to a hair-sized scratch on the mirror. Yes, so it's a very interesting point is, how will getting the James Webb out to L2, maintaining the mirrors, how will they, how will minor defect like that impact the resolution of the system? It'd be really interesting. And yes, new Starlinks are painted. So there have been updates. So from the very first set of Starlinks that are launched, there have been improvements to making them less reflective, so that they aren't as easily noticeable from the ground. Now again, it's hard to make something completely lack of emitting light, but there can be improvements that are made to try and make something much less reflective. Actually, very interesting. Another, I guess, self-plug for the recent video I uploaded. But in this video, we talk about a bunch of different accomplishments from NASA, and one of them that I was not familiar with up until doing the video was the Echo 1 satellite. There's actually multiple Echo satellites, and these satellites were launched in the early 1960s for communication satellites for NASA. Now, normally when we think of a communication satellite, we might think of something with this large antenna, talking back and forth with some ground-based antenna. Even kind of Starlink, like, a large constellation of satellites that can be used for the internet and, be able to communicate with space. However, the Echo satellites were not like that. They are essentially massive inflated balloons. They were, I think it was just over 30 meters in diameter, or 100 feet in diameter, and they wouldn't be inflated until they went up to space, but when they were put into low Earth orbit, they would be inflated into these massive balloons, which we could reflect radio waves off of and communicate with different locations on Earth. Now, I say that because if you think about something like that, a large constellation of those in space today, then that would probably be very bad for observational astronomy, because they will emit a lot of light, because not only are they going to emit radio light, but that's their entire purpose, is to also emit visible light, or different parts of the light spectrum. So although it would be very cool to actually be able to see these in space and to see one of these fly overhead, because it would be very bright, it would be probably as bright as the space station, if not maybe even brighter. However, in terms of in practical use, we've definitely been able to improve to use different types of antenna and structures for communications. So, it's this kind of give or take, that's a really interesting concept and something I would really love to see, but in practice, it's not not as applicable. Let's see. What do you think about the MOM mission from India? I believe it's the Mars Orbiter mission, if I'm correct. So yeah, so India, the Indian Research Space Organization, ISRO, launched the mission. I believe it was their first mission to Mars. Wow, back in 2015, so that was 6 years ago, around the same time that NASA launched the MAVEN mission. And they sent an orbiter, which I believe focused primarily on space weather as well as the atmospheric conditions on Mars. But yeah, that was a very important mission. I think I talk about that a little bit in one of my very early videos on the channel, where I go through all the orbiters that have been launched to Mars. So yeah, that's definitely a very, very fascinating one. Let me see. I imagine yes is to the Mars orbiting mission. So yeah. Yep, so SpaceX made newer Starlinks covered in black paint, and now they're overheating from all the sunlight they absorb. Oh, that is very interesting. I did not know that they were having troubles with the thermal system. That's a very, very interesting point. Well, I guess that's the give and take, you know. You have to, if you're going to collaborate to reduce one thing, then you might run into troubles with another. I don't know what the answer to that is, though. It'll be interesting, though, to see what all happens with that. And I guess another major component is you know, we have the Starlink right now is kind of, I don't want to say facing the blame, but you know, is a lot of that discussion is around Starlink. However, we also know that there's many other companies that also want to achieve similar constellations. So although a lot of discussion is around Starlink right now, there's also discussion that'll need to happen with these other providers, whether they're in higher Earth orbits, whether they have some kind of, you know, natural decay implemented. It'll be very interesting. I guess I can give you an update. It looks like we have the main frame, at least the bottom thermal protection system. You'll have the wheels right here. And then here's what I imagine will be a way to set the wheels up, but maybe not. Maybe they'll just pop out by themselves. We'll have to see how that works. Yes, India is doing great things in space. Unfortunately, they just recently had a malfunction on one of their missions. Uncrewed, very important. It was a robotic mission, but in I believe the third stage, they ran into a challenge which resulted in the end of the mission. But yes, they are doing some remarkable things. It's very effective for there to be collaboration across all sorts of space programs, you know, to be able to learn and grow from a lot of these concepts. Oh, they do have radiators on both sides of the solar panels. Yes. Yep. So, you know, the challenge of controlling the temperature in space. GeoSat 01. Is that the name of the one that recently had the issue? I believe that's what you're referring to. Yes, the geo-imaging satellite. Yeah. Excellent. A lot of really great questions today. And again, thank you for everyone that's tuning in. I really appreciate it. Building this space shuttle Discovery. anyone new, yesterday we built Hubble. Guess I can take it off the stand. Built Hubble, and on the back here is the NASA logo. A lot of fun with the star shield. Put that back on. We also have these little nameplates. So yeah, a lot of fun. Looks like we're almost about to be done with bag number 6. Oh, heat shield, yep. Bubble's still looking good, or bubble is still looking good. I guess I've been answering a lot of questions. I'm curious what some of you might think. You know, we've been talking about James Webb a lot. Do you think that James Webb will launch this year? Or do you think it might be until pushed back into 2022? I'd really like to hear what you all think about James Webb. I mean, I personally would love to see it launched soon. And I think it is on schedule to, but you never really know what can happen. And with that, we are finished with bag number 6. I'll put these last pieces on. Oh, I think I forgot something here. Yes, I did. With bag 6, we have a large part of the frame done here on the bottom. Exciting. Now on to bag 7. Looks like here we're building some of the edges of the shuttle. See what some of the comments are. I guess no one's quite sure about James Webb. I guess no one really is. We just gotta wait and see. I think the launch date is actually on Halloween, so... or October 31st. Seems to be waiting for an Ariane 5 slot. Yep. Yep. James Webb is coming up. For funding. Yes, so there's always challenges with various programs and the amount of funding that's available. I think that's just the rate of a lot of these scientific programs, is how fast things can happen for a certain amount of funds. India is also prepping for a human mission by the end of 2022. I think I do remember reading something about that. I didn't know it was 2022 though. It's very exciting. All right, bag number 7. Let's see. I'm starting out with some pretty small pieces here. Don't know how well you can see that. I know usually I want to build over here, but I don't know how well you guys can see that at all. But we're just putting a lot of these together. Actually, take a look at this. Yes, so it looks like I'm just looking up this crewed mission really quick. I don't know if I'm pronouncing this right. Giganyana, you might have to fix me there. But from what it looks like, it's supposed to be potentially crewed in 2023 and potentially uncrewed next year, which will be very exciting. That'll be an exciting launch. There have been some previous tests for re-entry and pad abort. Yeah, how long is this going to be? It looks like it's going to be a 7-day mission. Very exciting. Yeah, with the with the upcoming years, there's going to be quite a few crewed vehicles flying for the first time. You know, just this past year, we've seen Crew Dragon start to be implemented into Mission Space Station. We have Gagariana, if I'm pronouncing that correctly. We also, hopefully in the near future, will have Boeing's Starliner operating after their next test flight, that is. We'll have Orion, although it will be uncrewed potentially this year. You know, in the next 2 years or so, it will have crew going to the moon. Let's see, the other crewed vehicles. Not sure. We're building this, which I imagine is going to be the edge of the wing. We take a look. Or it might even be the edge of the fuselage. So I guess in another note, not necessarily related to James Webb or Hubble or crewed launches, but pretty exciting. I don't know if you all are aware, but yesterday the Ingenuity helicopter flew for the 12th time. I think the Jet Propulsion Laboratory said that it was a success very late last night or early this morning, depending on where you are in the world. It flew in a location where there's basically a bunch of sand dunes. So not where Perseverance could drive around really at all. Actually somewhere where they would not want to send Perseverance. And this is very important because, before the flight, a lot of the team was very concerned. Well, not concerned, but there was some say on one of the releases that NASA stated that this is going to be a pretty risky flight because Ingenuity so far has been flying, although it has flown over some sand dunes. Its sight essentially is this machine learning or this algorithm that looks down during the navigation part or the cameras and tries to decipher where's a safe place to land, where are the rocks, where are the where are these maybe larger boulders, what do we want to avoid, what do we want to land at. And the more it spends in an area where it's familiar with, the more confident the team is that it will land successfully. But on the contrary, when you start to go into regions like a sand dune where it's not as familiar, or landing somewhere can be potentially challenging or harmful to the helicopter, it can make it a little bit more nerve-wracking. So this flight specifically was going over a region where we didn't really want Ingenuity to land there, nor did we want Perseverance to drive there. However, it sounds like it was successful. From some of the pictures, it looks like it landed somewhere where it's a little bit more sensitive, or potentially could have even landed where it's tilted on one of these sand dunes. But I'm hoping that the next day or two there'll be another announcement with more details about what this exactly looks like, where it landed, some of the colored images, or some of the more pictures that it took during the flight, because that should be really exciting to see. And also, since this is a region where the Perseverance rover can't necessarily go, this is also one of our main ways of collecting data about this region. We can get images from a distance with Perseverance, but being able to fly over it at an altitude of around 10 meters or so, or 30 feet, can give us a lot more insight into what this actually looks like. So it's a really exciting program there. Let's see. LEGO Discovery, as it is now made me remember the Stargate Universe's Destiny ship. Yep. This is the midway construction point. Professor Snape, each rover should have a buddy drone. I agree. I think the Ingenuity helicopter has just shown, even thus far with 10 flights or 12 flights, it's been very successful. And I mean, we could even go further and say, okay, 10 flights is something, but maybe in the near future we have much larger flying vehicles. Now, there's definitely going to be a limit because it's hard to fly on Mars and you're going to need a lot of energy. But having something like this that can help you detect, where you want to go, or help survey where places might be useful is very helpful for the mission. So, here's the edge, as Gusto was saying, of the fuselage, kind of the base wing here that we were just building. That's awesome. What is the music called? That's a good question. So this is actually on YouTube's free library for music. It is called The Inner Sound. The public player, open sound. Yeah, Scout Buddy. I don't know. I think Ingenuity has really shown a lot of success. I'm hoping, fingers crossed, that it continues to be very successful. A major point of it is, originally during some of the early analysis or the early press briefings, it really was said to just be a technology demonstrator. And they have ran into a couple issues, some issues with one of the flights where it skipped a picture, so it didn't know exactly where it was, and very briefly went out of control, but it was able to land successfully. And scares like that are troublesome, but again, this is just a technology demonstrator. This is the first thing that has ever flown on Mars or on another planet, I guess with an atmosphere. So it's very exciting to see all these flights. And it will be very, very interesting to see how they develop for sure. I think I don't know. Not sure if I did or not. There's somewhere here where we have gray ones. But yeah, those are supposed to be gray. Alright, perfect. Just one of these is upside down and that's the one. So yeah, the Ingenuity helicopter has been awesome. Probably should make another video about it in the near future, looking at some of the pictures and the data that's come back from it. I wouldn't be surprised if, in the next year or two, there's another major announcement saying, hey, we're going to send another helicopter or a quadcopter or something to Mars. I think that'd be very exciting. Or maybe by its own mission, Rovers have, I guess probably not. I don't know how much in terms of scientific instruments it would be able to carry, because it is very challenging to fly on Mars. Even though it is lower gravity, since the atmosphere is just so thin, it really takes a lot out of the rover, a lot of power, and much like electronic aircraft here on Earth, every time you want to make something bigger, the batteries have to get bigger and everything kind of scales up a lot. So, but who knows? Maybe it won't be powered by, maybe it will be, chemically powered. Maybe it won't be electrical. But then that raises the question of, okay, well, if it's chemically powered, how much fuel do we give it and how long do we let the lifespan for? So, a lot of challenges. Oh, yep, the Dragonfly mission. Yeah, it'll help us learn a lot about Dragonfly. We talked about this a little bit yesterday too. Even though they're completely different vehicles and completely different worlds they'll be flying on, learning how to operate Ingenuity and some of the test cases and the flights as a whole will really help. Will really help in operating Dragonfly. Whoops. Put on a piece too early. Again, thank you for everyone being here. I really appreciate it. Having a lot of really great discussions about some fun space stuff, whether it be Ingenuity, James Webb, upcoming crewed missions. There's a lot of exciting stuff happening. For those of you that might recently joined, we're currently building the LEGO Space Shuttle Discovery, although it doesn't really look that much like a space shuttle yet. Kind of have the shape and the thermal protection. Currently working on the other side here for the edge of the fuselage. Yesterday we built the stand. I don't know if I pointed out the stand, but yesterday we built the stand for the space shuttle, and also Hubble, which has been pretty fun. Talking a lot about Hubble. So yeah, should be exciting, and this is what it looks like. It is all done. So I think right now we're building this part right here. Oh, that part. Enceladus is one of my favorite and it's one of the most interesting moons in your favorite. Yes, Bass Nation. Enceladus is very interesting. A lot of the moons of Jupiter and Saturn and Uranus and Neptune There's so much that we just need to explore, whether it be Dragonfly, whether it be the Europa Clipper mission, whether it be future missions out there. You know, there really are just these incredible worlds that we are just barely starting to uncover. Whoops. Again. Put a piece where it wasn't supposed to be, I believe. Oh no. Oh no, that's right. I think once we put this side on, I might read a couple of facts about some of the Space Shuttle and Hubble resurfacing missions. I think that'll be interesting. There have been quite a few of them, and it can help us, kind of put some of this Lego set and understand how the shuttle was able to keep this telescope operating. Yeah. I'd like to for the volcanoes, but Enceladus, Europa, and Titan are really interesting. Yes, Milky Way. Just like I was saying, is that there is so much that comes out of these missions. All these missions to Jupiter, all these missions to Saturn. We've been to Mars, and there's still a lot more we need to learn about Mars. I mean, from even the recent tests we've done on Mars, there's still so much we need to know. But Mars is, if we think about it, something that we've been studying for decades now, and there's still a lot we don't know. So compare that to these other worlds, like Titan or Triton, or moons of these large gas giants, and some of Saturn's moons, and understanding like how they formed and what the environments are like, and what does a day look like? What does a night look like? How does it precipitate? What kind of volcanoes are there? So many questions of these places where we are just so foreign to us that even though we've been able to study with some of these missions, there's still so much we don't know. And that's really what drives a lot of space exploration is, we're really going to these places to learn more about how, these moons are almost like experiments. They're almost like laboratories of all of themselves. And by going there, instead of having a laboratory where we have our little model of Europa and the environment and the atmosphere and the gravity, we can't do all of that. I mean, we can do some of it, like the atmosphere, but we can't make all the factors. So going there is how we really learn about what it's like. And maybe something that is so simple and ordinary and everyday life for us here on Earth, maybe a geological structure or some formation or some kind of, reaction is something that just doesn't happen somewhere else, or maybe it does and can teach us. And, kind of like what I was saying yesterday is like that eureka moment that, oh, that's weird. That can lead to, understanding how everything works on a much larger scale. That's really what all this is about. It's about learning. Let's see, I like to, yep. I wonder how the discoveries of life on Enceladus, Titan, or Europa would redefine the definition of Goldilocks zone. That's actually a really interesting point. I read somewhere recently the idea of Goldilocks zone and the fact that there's a new type of definition for Goldilocks zone, not necessarily definition, but a new type. And that is locations, it's called like a tidal Goldilocks. So instead of being so close to a star, for example, the Goldilocks zone, instead you're so close tidally to an object. So really quickly, for someone that might not be aware of what exactly we're saying, the Goldilocks zone is a region that is used for astronomy or for, I guess, astrobiology. But basically, when let's say you're a planet orbiting around a star. If you're too close to the star, it's going to be too hot, and liquid water cannot be present on the surface. So for example, Venus. Venus is too hot for liquid water to exist on the surface right now. So therefore, it might be on the edge of a Goldilocks zone, but it's too hot. On the other end, you are too far away from the star, and even though you might have water, it's just going to be completely frozen, and it's too cold for liquid water to exist. So for different stars, and depending on how bright and how hot they are, we can calculate how far a planet needs to be in the Goldilocks zone. Where, just like in the story Goldilocks, Goldilocks had the soup and it was too cold, then had the soup and it was too warm, and then had the porridge and it was just right. So Earth is in the Goldilocks zone. We have vast oceans of liquid water. Mars is also, I believe, in the Goldilocks zone or on the edge of it, but it's a little too cold and a little too small because it doesn't currently have liquid water. And the atmosphere is too thin. But then there's a new way of saying, okay, well, we could be this close to a star or this far away from a star. But there's this new idea of, well, wait a minute. What if instead of being close or far away from a star, what if we're close or far away from something really heavy, like Jupiter? Because what can happen is if you're close to Jupiter, when you orbit around Jupiter, just like how we have tides here on Earth, the moon causes the tides of the ocean to come in and come out. What happens near Jupiter is that not only are there tides, but it can actually change the shape of the entire moon. It can change the rock, the structure. And what this causes is it causes internal heating. So it's kind of like squishing down the moon depending on where it is in its orbit. And when that happens, essentially what you end up getting is gradual tides, or you get this heating that happens instead of coming from a sun. It comes from inside of the planet or inside of the moon because of the gravitational tides. So a Goldilocks zone, so some people are saying that, okay, well, we have this Goldilocks zone for being around a star, but maybe there's also this tidal Goldilocks zone where, if you're too close to Jupiter, or too close to a really large planet, or too close to something that's really heavy, then you're going to get too much tidal heating. You'll have a lot of lava, a lot of magma, and it will cause these massive volcanoes, which is what Io is like. On the other hand, if you're too far away from a star or something massive like Jupiter, then you'll get a little bit of tidal heating, but it won't be enough to keep something liquid. Whereas if you're just in the Goldilocks zone for these tidal regions, and Europa is an example of this in Jupiter, then you can have you can have massive amounts of liquid water, and that's thought to be underneath the crust in Europa. We have this tidal lock zone in terms of, we're trying to look at other stellar systems or other exoplanets around other stars and find which one might be Earth-like. But really what we might be looking for are these icy worlds, these frozen worlds which have liquid oceans underneath their surface. And although life may exist there, it might be very different from what we're aware of today, exploring those places and understanding those places will really teach us a lot about, how things form, astrobiology, all this exciting stuff. So yeah, that's a very good point. I'm glad you brought that up, Professor Snape. Enceladus has water, so it can. Yep. So recently discovered water on Enceladus. For most hope for human settlement, and sun gets big, it can even start raining and get into the habitable orbit. So one of the challenges with Enceladus though is very, very, very heavily radiation zone. So since Enceladus is orbiting around Jupiter, it's exposed to high amounts of radiation, and that can be a very big challenge for sending people to Jupiter. But again, radiation is a problem that we're going to have to figure out if we're going to be sending people really anywhere. So that is a good point. If we build a city on Mars, then it would be near the poles because of the frozen water. Yep, so that's a really good point. A lot of, especially the North Pole, has a large access of liquid, or I guess frozen water, which could be very useful for, let me make sure I did this right. Oh, I need to flip it one over. It can be very useful for collecting water. I do imagine that if we build, I guess one of the challenges though, if we build something near the pole is energy. I guess if we have access to water, then we can use, we can get oxygen and hydrogen and burn that for energy. But at the same time, in order to get oxygen and hydrogen and to burn it for energy, we need to use energy. So having access to energy near the poles will be challenging because during the seasons when it's perpetually dark, we might not have enough solar technology to do that. Then we can go to nuclear, which could also be beneficial. However, that's just something that needs to be kept in mind for designs. It's just like on Earth during a winter in the southern hemisphere. That's gonna basically mean that if you're at the poles, it's gonna be dark for a few months. Oh, Enceladus is Saturn's moon. Oh, okay. Oh, I was thinking of Ganymede. My apologies. I was thinking of Ganymede just recently had water discovered there. So yeah, so going to Ganymede would be a big challenge. But Enceladus, yeah, I'm not quite sure. I'm not quite sure how much radiation there is near Saturn. But yeah, Saturn also has Triton, or Titan, not Triton. Triton is Neptune. Triton. I think I said the same thing. Titan is at Saturn. Triton is at Neptune. But yes, that's a major component of some of these frozen worlds out there in the outer solar system. Yeah, but this is a very interesting discussion. Thank you guys. I guess you can't really see what I'm working on right now, but I'm working on what I believe is going to be one of these back edges of the wingtips. So right around here, or on this side, I'm not sure which side, but we are potentially making this, or it might go like this. And I continue these edges that we have made up here. So I remember asking, I think this was like a Twitter poll or something a few months ago that I ran. But I remember asking this question, would you rather go mountain climbing on Mount Olympus on Mars, or would you rather go scuba diving in the oceans of Europa? Assuming that you have all the right, gear and everything and that you won't freeze wherever you go. But would you rather go scuba diving in the oceans of Europa or mountain climbing on Mount Olympus or Olympus Mons on Mars? And I think that's a really tough question. I thought about that for a very long time in terms of which one I would rather do. Because, Olympus Mons would be incredible to walk around on Mars and to climb that massive mountain or massive dormant volcano. This is the edge, the finish of the edge, which we'll be putting on. It would be really fascinating to do that. But at the same time, it raises the question of, well, I also would want to go to go see what it's like to scuba dive in Europa. We've never really visited, or we've never really seen what Europa is like there. So I think that would be incredible. That's where that goes. Oh, whoops. I did forget a couple things there. So yeah, it would be really exciting to go scuba diving on Europa. Need to go back a couple pages. fixing up one of these parts here. I noticed that there was a couple of these missing right here. I don't know if you can see that. These two were missing, so I'm actually gonna fix that up really quick. Want to make sure we do it right. And just like that side. Perfect. And we just added this edge. Milky Away says, I remember that. I couldn't choose, but maybe scuba diving to see how a shark might look in Europa. If there are sharks in Europa, that would be awesome. I think you're kind of taking the risk. You know, you're like, okay, well, maybe Europa has this incredible ecosystem of alien fish and, you know, squid-like, you know, something completely out of what we could ever imagine. But then you also can go and say, well, you know, maybe it doesn't have that, and you're just going to go scuba diving in a very pitch dark ocean. But it would still be really cool to see what the geology and the structure looks like there. I don't know. It would be a very hard choice no matter what. I mean, look, climbing on top of Olympus Mons, it would be surreal. I mean, you'd be going so far up into the atmosphere that I wonder if it would still look, you know, this grayish color that we see in pictures, or if it would even start to go to black, like going into space. But I don't know. I don't know. Or maybe Valles Marineris, the large valley that scrapes across Mars, you know, many times the size of the Grand Canyon. That would too be pretty incredible to see. There are these truly phenomenal places in our solar system, and there's truly phenomenal places just here on Earth. There are so many places to explore. I would go to Titan because humans could fly there with little effort just by flapping our arms. Yeah, if you have, I think I created a video about that maybe a year and a half ago or 2 years ago. But yeah, if you have the right wingspan, or, you know, if you add something to your arms, you know, you pretend to be a giant bird, and you too can fly across Titan. I feel like it'd be pretty tiresome. Well, the reason why is because the atmosphere is denser than that of Earth. So first of all, you're going to be, you know, in this more dense atmosphere, not as much as Venus. It's just, I think, a couple times more dense than Earth, so it's bearable. But since it's a moon, its gravity, or since it's a moon and it's less massive than Earth, its gravity is lower on the surface. So you have this perfect combination of a more dense atmosphere, meaning you have more air to work with in terms of actually, you know, flying. And on the other side of things, you have lower gravity, meaning that it's easier to actually fly. So unlike Mars, where the lack of atmosphere makes it very hard for anything to fly, and, you know, Ingenuity has shown success, that just because it's successful doesn't mean it's easy. But then you kind of turn around and ask, well, you know, if we go to Titan, then we can just flap our wings and fly around, which I think would be pretty awesome to see. It'd be pretty awesome to see some astronauts just, you know, flying around, whether it be with gliders as wings, or even just kind of like a little jetpack, just going around. Let's see, Love Gupta. Okay, bye guys, it's getting late. Nice talk. Thank you again. Thank you, Love Gupta, for hanging out. I really appreciate you being here. And thank you to everyone that's here. I really appreciate all the conversation. It's always fun to talk about these types of things. So again, we're building this front edge, I guess, right here. Well, I think it'll be going on like right there, but we're not done with it yet. We're finishing off the edges here. So we're getting pretty close to being done with bag number 7, I believe. Bass Nation says climbing on Olympus Mons to see the view at 21 kilometers. Yeah, so, you know, the view would be pretty amazing on top of Olympus Mons, but there's also an interesting note that, you know, it's not like a lot of mountains that we would envision here where they have these massive peaks, you know. kind of protrudes out of the ground. We get that here, but on Mars for Olympus Mons, it is a much more gradual slope. So although it is a massive mountain or a massive volcano, dormant volcano, it is a lot more gradual. So I believe if you were on the top of it, you wouldn't even be able to see the base. You would just essentially see this gradual, well, it would still be a mountain. You could look around for very far, but you'd more see this gradual declining hillside, which would go all the way to as far as you could see in the atmosphere, which is hard to imagine what that would even be like. Maybe one day we'll send something small to Mars to get a picture from the top. It would actually be really interesting for a Mars mission that instead of being, one large rover, we send, 20 or 30 Ingenuity-like helicopters to different locations. Because the challenge is when you have something like Perseverance, you want to land it somewhere where it's going to be safe, because, all of your marbles are in one basket, or all your eggs are in one basket. It has to land successfully, and it has to go to these regions where you have to be very careful. And Ingenuity, since it's a technology demonstrator, we can be a little bit more careless with it, because if Ingenuity, something goes wrong with it, we still have Perseverance. But if you send 50 Ingenuities, and you're like, hey, we want to land on top of Olympus Mons, let's land there. Then you can do that with one, and if that one doesn't work, that's perfectly fine. We can land some other ones. The only problem is once you land 50 things, you have to have landing and descent for 50 things, which, if that includes, a power descent or sky crane maneuver, that could be very hard. But if it's like a parachute or an airbag, like the Spirit and Opportunity rovers use, then maybe that's a little bit more realistic. But I always thought that would be an interesting idea for a mission is, instead of having one large rover, have a dozen or so, or a bunch of mini missions that could relay back and forth. But that would be really cool. And Milky Way says, yes, at 25 kilometers high, you'd be halfway to space. Yeah, so if you're on top of Olympus Mons, you're really getting up there. So I don't know how much in terms of actually seeing, how much it would make a difference, like seeing in the atmosphere. I imagine you'd still probably have quite a sky, but maybe not. So we put on these two very large blue pieces. I'm not sure why they are designed to be blue or teal, but it's pretty interesting. Here's the outline of the shuttle so far. Putting on some of these edge pieces. Oh wow, we finished with bag number 7. We still have these pieces that we can put on though. Let's build this. Building these little tiny pieces that could kind of on the corners here. We go right here. So it wraps around, and wraps down, and comes to near the nose, but we haven't built that yet. But yeah, picking between, going to Olympus Mons, climbing the massive mountain, or scuba diving on the ocean world of Europa, I think that will always be a tough decision. No matter who you ask. Alright, on to bag number 8. So the nose, so this is another fun fact that's included in the book here. The nose and the leading edges of the wings can take a re-entry heat of up to 2,912 degrees Fahrenheit or 1,600 degrees Celsius. So I imagine it's probably talking about the pieces that we just built. So here, you can take up to those incredibly high temperatures that are required from re-entry when we're coming back from orbital velocities. Which is really interesting. You know, it has to sustain it and then also has to be reused, so there's probably a lot of maintenance that goes into that. All right, number 8. Milky Way says, I heard that the cliffs on Olympus Mons caldera were 5 kilometers high. Imagine being on the edge of that looking straight down. Oh yeah, that is 5 kilometers, that seems like a lot. So, you know, if you're definitely on the top there, that would be pretty impressive to look at, nonetheless. You know, there are some very interesting images from various comets and I believe, not sure about asteroids, but definitely comets that, you know, we see these landscapes of these asteroids or, you know, these smaller bodies in our solar system, and it's hard to imagine what these scales are because, you know, they are multiple miles across or multiple kilometers across, and they're just cliff sides or massive steeps or, you know, huge regions where, you know, there isn't very much gravity, so just seeing it would look so surreal. There's no real up, there's no real sideways. There is kind of a down, but the gravity's so weak that, you know, if you jumped, you would just leave. So, I don't know, it's very surreal. Really interesting. But with that being said, let's talk about a couple of fun facts about some of these Hubble servicing missions. I think that would be pretty important. So this is coming from NASA's website. Let me actually save this image really quick. I'm gonna share this with you all. Let me see if I can do this. So this is coming from NASA. Make that a little bit bigger for you. Okay, there we go, cool. So the Hubble Space Telescope was first launched in 1990, so 31 years ago. And after it was deployed, this is coming directly from NASA, the observatory's primary mirror was discovered to have an aberration that affected the clarity of the telescope's early images. Fortunately, Hubble was the first telescope designed to be visited in space by astronauts to perform repairs, replace parts, and update its technology with new instruments. Astronauts first visited Hubble in orbit on December of 1993. Including that trip, they had 5 astronauts servicing the Hubble. So this picture that we're looking at is of a galaxy, or the core of a galaxy called M100. And on the left is a picture that we would have gotten from the Hubble before the servicing was set up. I hope you can see the picture. So on the left is essentially what we saw, or what would be seen from Hubble before the mirror was replaced. And on the right is essentially what would be seen after the mirror was replaced. So we could see how there was a pretty large challenge with that mirror. So the first servicing mission, let me see if I can pull it up really quickly. So the first servicing mission was actually not performed by Space Shuttle Discovery. It was performed by Space Shuttle Endeavour in mission STS-61. And the main focus was to, you know, install or fix the flawed primary mirror from Hubble. So that was a pretty important mission, nonetheless. And this took place 3 years after Hubble was first launched up there. So I can imagine that there's probably a lot of stress on on doing that. So yeah, that's pretty exciting. All right, let me take that picture down and let's keep building. So 1993, Hubble's primary mirror was fixed. Oh, let me fix that. Go. Perfect. All right. So let's get back to building. We need to open this next bag, which is number 9. Oh no, we already opened number 8. Never mind. On number 8. They actually gave Hubble's pair of glasses. Yes. Yes, they did. Perfect. All right. So it looks like we're adding some of these pieces right underneath these landing gear like suspension things that are right here. Fairly interesting. So I guess another major mission that's coming up in the near future is the commercial resupply mission, which Cygnus just launched, I believe it was last week or 2 weeks ago, to the International Space Station to bring some resupply, some instruments, as well as some supplies to the International Space Station. But also, in the coming future, Dragon 2 will be launching also a commercial resupply mission, I think the end of this month, so in the next 2 weeks or so, which will be the first time a Falcon 9 has flown since, I believe, August or June. So it's been quite a while. We've gone quite a bit of time without a SpaceX launch. So it'll be exciting to see one of those again. I guess I say quite a while, but then, it's also been quite a while since we've seen, many launches over the last couple of months, except for the Cygnus one. So from the United States, there was a launch last night that had a bunch of CubeSats on board. Oops. All right. So yeah, we're building, I'm not quite sure exactly what we're building. We might be building a part of the top of the shuttle. I'm not sure. I guess I could show you what it says on here. What it's showing. I don't know how well you can see that. There's quite a large glare. Maybe that's the nose. Oh, this side. This side. There you go. That might be the nose. I don't know exactly what this is, though. We'll have to wait and see how it goes on. The Vega launch from the European Space Agency, yes. Yes, that was, I guess just over 12 hours ago now. Maybe a little more than that. Still pretty exciting. Here's this, which I'm guessing is gonna go on this way? Yes. Yes, so that's actually the rear. What we're building now is gonna be the rear part of the shuttle, near where the engines went on. So I guess I can give some fun facts about the shuttle as we're working on the shuttle. The space shuttle was fueled by liquid oxygen and liquid hydrogen. During the launch, there was the main orange tank, which is not included in this set. So here we can see what the set actually looks like. Again, I've shown this a bunch of times, but we'll look at it again. The external tank, the big orange tank, is not here. It's not in the set, which is okay. We have the whole space shuttle. But the orange tank would hold a lot of the fuel, and then when it wasn't needed anymore, then it would be dropped. But alongside the big orange tank were the solid rocket motors, or the solid rocket boosters, which there were two on the side of it. So those would ignite, fall off, and then the orange tank or the external tank would fall off and would leave the shuttle. Now, the shuttle was actually, it did not have solar panels. It was not solar powered. It used fuel cells. So it actually used the liquid oxygen and the liquid hydrogen that it used for fuel. It also used that for its power source, for its electronics. And this was also really useful because that process would generate water. So not only would they get power from their fuel, but they could also get water from their fuel. So that's a major design in the space shuttle, and a big difference between, some of these other vehicles that use kerosene or rocket powered one, or rocket propellant one, not rocket power one, rocket propellant one, or methane, I guess, more recently. So pretty exciting. It's a pretty exciting concept, for sure. All right, so this is now going on the end here. Right, like this. Again, I think this is going on the back of the shuttle, so this will be kind of the rear near the engines, kind of like what I was mentioning before. But the space shuttle was primarily ran off of or its engines were, again, used hydrogen and oxygen, and were the RS-25s, the space shuttle main engines, or the RS-25, which is a pretty incredible rocket engine that were very effective in terms of the development of reusability, especially for hydrogen and oxygen, and is actually the same engines that are going to be used on the Space Launch System. The first stage has 4 RS-25s, or Space Shuttle main engines. And over time, they were improved, so the design for the Space Shuttle main engines were improved, and were able to become a little bit more efficient. Milky Way, how do you feel about the Starliner? That's a very good question. So Starliner, so I guess I should kind of give a little bit of a backstory. Before the space shuttle was ended, so the last space shuttle launch was in 2011. Before the space shuttle program was ended, NASA was interested in making sure that they could get not only cargo but also astronauts to low Earth orbit. And a big focus for NASA, transitioning as the shuttle would be decommissioned, or essentially, the program would go to an end, they wanted to make sure that they still would have an availability of launching astronauts and cargo to the International Space Station. First, it was cargo. So Cygnus or Northrop Grumman and SpaceX won contracts to develop cargo resupply missions. So CRS, whatever number of missions. So most recently, the Cygnus launch, the up-and-coming SpaceX launch, the Falcon 9 launch, those all began back in 2008. When there was this idea where we should have, these private companies being a main contributor to launching cargo to the space station. So the few years following that, as that was shown to become successful, they were also interested in sending crew to the International Space Station. And that's also because at the time, the United States did not have a way to send crew to space. So therefore, they started the Commercial Crew Program, which would basically be very similar. A private company with their space capsule and whichever launch vehicle they selected would fly a crewed capsule to the space station, whether it be for American astronauts, NASA astronauts, ESA astronauts, the European Space Agency from Europe or Canada, international effects, or cosmonauts. Essentially, they wanted to have the ability to send people to the International Space Station or to low Earth orbit. So basically, fast forward to today, or fast forward to a couple years ago, SpaceX and Boeing were selected, and Boeing's Starliner vehicle was selected, and SpaceX's Dragon vehicle was selected. Now, it was originally planned that Starliner would be the first to send people to the International Space Station. However, due to some challenges with their first flight, they essentially had to put that on halt, and essentially they had a lot of software issues with their first Starliner flight. There was a clock delay. There were quite a few issues that ultimately led to not only was Starliner not supposed to dock with the International Space Station, so they essentially had to end the test early, but they also ran into some issues with actually being able to perform the maneuvers to get to where they would need to be, or having the propellant. So therefore, the first test kind of showed that there was a lot of improvement that was needed for Starliner. And SpaceX also had some improvement as well, but they were able to quickly make some changes and have shown quite a bit of success. SpaceX has shown a lot of success in that, they've already performed Demo 2, which was the launch of Bob and Doug back in last May, which was also the first time that, I think Jim Bridenstine loved to say, to launch American astronauts from American soil on an American rocket since the space shuttle. So that was a big point. But they've also launched Crew 1, Crew 2. So Crew 1 was last fall, Crew 2, which was this past winter, and Crew 3, which will be coming up shortly. Actually, I believe Crew 2 was during the spring. I believe that was in April. And then Crew 3, which will be coming up in about a month or so, or 2 months. So SpaceX's Crew Dragon has shown a lot of success. However, because of some of the challenges that Starliner ran into, they've kind of been put on a hiatus. So they were planning on launching more recently in a couple months ago, I think it was earlier this year, but due to the launch vehicle that they're on, the United Launch Alliance, they essentially had to wait until July. And then most recently, they had to wait in July, and after some of the delays with some of the issues that were happening on the space station, they then had to wait, or they noticed that there was an issue with some of their valves, and they had to bring it back into the assembly building, not the assembly building, but the vehicle maintenance building. I don't know exactly the name of it, and test the valves, and then they noticed that they had to do some more analysis. So they had to take the Starliner off of the Atlas. So essentially, they are kind of behind in terms of what their initial plan was, because originally they were trying to get a lot of this done in 2018, 2019, and then 2020s, but now it looks like it might be another few months or so before they'll be able to really be able to do their second test. And that's even before their crewed test. So they have to do a second test where they dock with the International Space Station, and then they'll have to do a crewed test. So it will be some time, I think, unfortunately. But I do hope that they succeed. I know that there's been a lot of work and effort put in, and I do know that SpaceX has shown a lot of success. But at the same time, we do want to have multiple vehicles that are capable of sending people to the space station. So hopefully soon it'll be good. So Bass Nation asks, so Starship also needs to use fuel cells because I don't think it has big enough water tank to refuel or to fulfill need for transit. That's a good question. So it might need to use fuel cells. I guess it really just depends on the design for what will happen in transit from Earth to Mars or to wherever it plans on going. I don't know. I believe I've seen schematics for solar panels on the Starship. That might have been some of the much earlier designs. But there will definitely be something necessary in order to power the vehicle and whoever is on board. So that'll be something we'll just have to wait and see, I guess. All right, let's see what's going on here. I think I have this up by one too far. Let's see, that's 6 there. Oh yeah, I might have accidentally put this in one too far here. Actually, I don't know if I did or not. Let me check. Let me see what some of this might need to come off. Yeah, I put it in one too far. That's okay. Let me take these out. But yeah, hopefully by the end of this year, early next year, Starliner will be able to perform some of their tests. And then maybe by mid to late next year, they'll be able to do a crewed launch. I think just the most recent challenge that they ran into really had to slow them down, because not only is it they have to make some changes to the vehicle, but they also have to wait for an available launch vehicle. And with some other upcoming missions, some of them take priority. So it's kind of this waiting game. It's a combination of them having to make updates and also wait for an okay time to launch. It's funny, I put this back on, but I forgot to put the main part back on. All right, you're coming back off. But yeah, a lot of interesting questions. So how does this go back on? I That goes there, I believe. Let's double check. Yes, that goes there. And then these need to go on here first before I put it back on. Yes, these need to go here. And this needs to go there. All right, let me double check. That's there, perfect. Whoops, there's a piece in the page. Go on in there, and then we put these in. Keep it strong. Good night, Bass Nation. Thank you for coming. I really appreciate it. Yeah. Yep, Milky Way, you're exactly right. It doesn't have enough ports, and there's also some overlaps with the Atlas V for the upcoming Lucy mission, I believe. I think I'll be making a video about that in a month or so. But yeah, that'll, you know, really it kind of is this waiting game for Boeing. Let me see this. By the way, SN20 has moved closer to Bad B. Oh, that's exciting. Oh, you might have already left. Yeah, SN20. I think it's been moving back and forth for all the tiles, but it should be exciting to see what all it's capable of testing and doing, and hopefully it might be the one that actually goes to orbit, which would be really exciting. Lucy is the asteroid one, the Trojans. Yes. So Lucy is the mission that is supposed to be going to a bunch of Trojan asteroids, which is why the Atlas V has priority over that mission. To essentially make sure that it is ready to go. Oops, I again put this in backwards. This time it wasn't as crazy. I think I keep putting this in just one too high. There we go. Oops. I say there we go, and then it kind of falls apart. Perfect. All right. That needs to go back there. These need to come back on. And the blue one. Yeah, I wonder, out of curiosity, I wonder when the first orbital launch of Starship will be. I know there's a lot of regulations or whatnot that need to happen, but I think it'll be, I hope that it happens soon, that we can watch it and see how well everything goes and learn more about everything. Yeah, Lego space is hard. I don't think it's as difficult as actual spaceflight, but it is definitely can be tricky sometimes. I was running into a problem, I guess I could show you right here with the this landing gear in the front. I kept putting it in the wrong slot on this 1x6 or 1x8 here, the long loop, and that kept making the wheel get stuck. So I didn't want it to be stuck, because that would not be good, and not be good for landing with a stuck landing leg. Looks like we're almost done with another bag as well. We've been doing pretty well today. It's like, oh, it looks like there's one thing that we might be missing. Because there's two of these, and whenever there's two of something, I think that means you did it wrong, or I did it wrong. Let's see where I might have done something wrong. But yes, this needs to go in here. Forgot to put that back in. Let's see. I'll be glued to the TV for $20. Or sorry, I thought I said $20. SN20. Yes. Yes. SN20 and booster 4, or whichever booster, or whichever SN, that orbital launch will be getting a lot of attention and will be very exciting to see. I hope they have a lot of good camera angles for that. Alright, so finished another bag. On to bag number 9. Well, this one's pretty easy. Sort by color, because it's all the same color. Again, some of these pieces that already have the stickers on, really appreciate those. NASA's Discovery and US flag. But yeah, if I had to guess, probably SN20 and Booster 4 probably won't launch for another couple months or so, just because of testing that might be needed as well as some of the regulations. It will be interesting though to see if they test all 20, I think it's 29 boosters of the or 29 engines, not 29 boosters. 29 boosters would be crazy. 29 engines for the booster, because that would be pretty phenomenal to see. So I realize what we're building now is the base of the cargo bay or the payload area right here. That should be pretty exciting. And I put a piece in the wrong place. Perfect. Yeah, so we're putting on some of these pieces in the cargo bay, then on the back for the aft of the wing. Yeah, Milky Way says, I wonder if the pad will handle the 29 Raptors. That will be crazy. It really will be. It'll be hard to fathom 29 Raptors. So we have another Did You Know for, I'm guessing, this region, but it says, when the orbiter enters the atmosphere at Mach 25, its velocity is so fast that it superheats the surrounding air and returns to the Earth in a glow of plasma. So yep, so as it's returning from orbital velocity, basically creates this blanket of air around it that's just so compressed, generates a lot of heat and a lot of plasma. It's essentially kind of acting as, you know, a meteor, but trying to stay intact as it does. We also have another Did You Know on the very next page. Giving us a lot of fun facts in this book, or this bag. We're putting on the wings here. Is the left half. And let's put on the right half as well. Yeah, I think a big part of the test, if there's 29 engines, is, you know, yeah, will the pad handle it? Will they do all 29? Will they stop at a certain number? You know, will they test all 29 but individually? You know, sets of 3, sets of 10, or I guess 6. You know, how will they go through it? It's something that's very new and different from all the past tests. So this page says the Space Shuttle Discovery is covered in approximately 23,000 ceramic insulating tiles to protect the vehicle from intense heat of re-entry into the Earth's atmosphere. Yep, so all these ceramic tiles are useful for making sure the space shuttle is good. And then, you know, when some of them would need to be replaced between flights, they'd go in and check the numbers and check the tiles and replace them, and then get ready for the next one. I guess somewhat similar to the tiles that SpaceX has been putting on, although they are pretty different in, you know, the geometry and shape and even somewhat of the composition. You know, a lot of the knowledge we learned from the space shuttle can be applied to what we do now, which is very cool. All right, we're putting on more of these tiles. And then these 4, and we're already on to bag 10. That was very quick. Alright, so there, you know, that is definitely starting to look like the shuttle. With the payload bay, the wings, the leading edges, and I guess thermal protection, which is kind of the back plates of these. But definitely starting to look like the framework. We're getting on to bag 10, so definitely making a lot of progress. Yep, so Milky Way says, the catching of the booster mid-flight, I really don't know. If they pull it off, it would be, don't even have a word for it. Yeah, the ability to catch a massive booster in air at the launch pad, very ambitious. But if, you know, I mean, they've shown recently, especially with some of their flights of the Falcon 9, that they have definitely improved on their landing capabilities and, you know, how well they can land on a drone ship in the middle of the ocean, or a barge, I guess. So if, you know, if the, I guess I should probably move this over here so it's easier to see. But if, you know, if they're really trying to land near launch pad, well, that's something else that they've shown can be pretty effective. But if they try and launch on a launch pad, you know, in a very small area and try and catch it, then that can be a lot of trouble. But it will also be interesting because technically speaking, you know, it'll be going very slow, so, and the engines can take up a lot of the power needed to actually catch it. Or a lot of the force, I should say. It will definitely be interesting to know, or to see how all that plays into a role. Alright, so we need another one of these. Another of the... I think I'll read another one of these Hubble servicing missions. So the last one we read was the first servicing mission after the launch. So the first launch was in 1930, where Hubble was first sent to orbit on Discovery. And the second mission, which was by Endeavour, was 1993, when, did I say 1990, sorry, is when Hubble was first sent to low Earth orbit. And the first servicing mission was 1993. The second servicing mission was in 1997, so 4 years later, where this time Discovery, so the shuttle that we're building, Discovery, it performed a second mission where it was sent to, let me see what this says. It was sent to improve Hubble's capability to extend the wavelength range to near-infrared and imaging and spectroscopy. So this is kind of what we're talking about with James Webb, where James Webb will be imaging infrared, where in this servicing mission, it improved some of the instruments to allow it to see further into, or a wider range of wavelengths or light. So it improved some of the science productivity, changed some of the maintenance that was needed on board, and also updating some of these instruments. So it was a 7-member crew where 4 astronauts conducted spacewalks to maintenance Hubble for the second servicing mission, the second of 5. That's pretty exciting. All right. Let's keep building. Here we're going to be building parts of the aft again. This again, I think, is kind of playing a role in the landing legs of the set. Let's see. There. This goes here. And this is going to go behind this. Double check to make sure that's the right place. Actually, I think it might even be one further back. Yeah, it's one further back. So there's been a lot of missions that have gone into making sure that Hubble is operable. And it's a major part, you know, Discovery, Endeavour, resurfacing, servicing. Definitely takes a lot. But it's been an incredible tool for the last 30 years. And a lot of that comes from, you know, the initial design as well as the ability to service the vehicle. Oops, these came off. Troubles closing Hubble's door after servicing. Do you mean the door at the front? I'm not sure if I read that. Let me see. Shuttle. Let's see what this says. So I guess this is just another fun fact from it. How Discovery maneuvered after the end of all the EVAs. Discovery performed its final maneuver to redeploy Hubble on February 19th, at an altitude of 335 nautical miles, or 620 kilometers above sea level. Initial checkouts of the new instruments and equipment during the mission showed all were performing nominally. Calibration of 2 new science instruments took place over a period of several weeks, with first images and data anticipated in about 8 to 10 weeks afterwards. That's exciting. All right, we added those. Now, let's keep going with kind of this back half of the shuttle. Oops, dropped a piece. We're building this very interesting thing. I don't know how exactly to explain it, to be quite honest with you. It looks like it might go onto the side. Maybe we'll be adding more pieces to build it up. But we put the pieces on like this. I don't know how well you can see that. We have these pieces. See, that gets focused. Doesn't want to focus. It's okay. And we have these pieces stacked on top of each other. We put them through the holes in the center here to go there. I think that's pretty interesting. Don't know exactly what that's going to be working towards. And I imagine we're going to do it again on the other side. Yep, there it is. So other than SpaceX's upcoming commercial resupply mission, which is the end of this month, and after that I believe there's going to be a Starlink mission. Very exciting is going to be the Inspiration 4 mission, which will be happening about a month from now. So if you aren't familiar, Inspiration 4 is a mission that was funded to help support, I think it's St. Jude's Children's Hospital, and in the fundraiser, essentially you could win either. One person was auctioned off to win a flight on a Crew Dragon to go to orbit for a few days. There was the founder or the funder of the mission that's going as well as a couple of, or a nurse from St. Jude's and a science communicator. So in a month from now, there'll be 4 civilians who will be going up in a Crew Dragon. They won't be going to the International Space Station. They will only be going to low Earth orbit. But that's still very exciting, because this will be really, a major first for SpaceX in sending. Essentially, this is kind of like space tourism, but it's through a fundraiser. So it'll be really interesting to see how the Inspiration 4 mission goes, the coverage of it, what all they talk about, any images, or any publicity it gets. It'll be a really exciting time. So I'm personally really excited to see the Inspiration 4 mission go. And also, I know that there's a bunch of other talks about probably upcoming space tourism flights. So I think that'll play a pretty big role in kind of, the future here of space tourism. Pretty different from some of the suborbital flights that we've seen this past month or 2 months. I guess it's really been in the past a little bit over a month, which is pretty insane. But with Richard Branson's Virgin Galactic and their flight of 6 people, as well as Jeff Bezos's Blue Origin, it's really interesting to see. It's really interesting to see, space tourism really picking up. Because at least for the last few years, if not maybe even the last decade, it's always seemed like space tourism was something that was always a couple years away, whether it be, 2 years, 3 years. I mean, Virgin Galactic, I think originally was planning on the early 2010s and was selling tickets, for the early 2010s. And, they've only just recently, shown with Richard Branson flying and some of the members of the company. But even then, there's still, some more tests that need to be run for Unity. And Blue Origin claims that they're going to be having some more commercial flights or some space tourism flights later this year. So it's pretty exciting to see it on the forefront. It'll be really neat to see how, whether it be orbital flights through SpaceX or suborbital flights through Blue Origin and Virgin Galactic. It'll be exciting to see all those play out and how frequently a lot of these are really going to space, because I know I imagine it's a few hundred people that have already bought tickets for some of these, maybe even a few thousand. But at the rate that it's going now, if there's 6 people on board one of these vehicles and there's a launch every month, to reach a few hundred people can take 10 years. So it really needs to pick up the pace in order to maybe fulfill some of the tickets that have already been paid for. But yeah, it's a pretty exciting time. Definitely exciting time for space travel. But we're building this. Don't know exactly what it is, but we'll see how that goes on soon. Next, add the phasers. Add the phasers to the planet, or to the space shuttle. I don't think that's included in the set, unfortunately. No phasers. Which one would you choose if you could only choose one, Blue Origin or Virgin Galactic? That's a very good question. So Blue Origin, I guess to kind of talk about the experiences first. Kind of from a very basic standpoint, Blue Origin, is this New Shepard rocket where you strap into the rocket. It's the countdown. It's the whole ordeal. T-minus 5, 4, 3, 2, 1. You launch off. You spend a couple minutes in, 3 Gs, a few Gs, getting up to the altitude needed. And once you get there, the main engines stop, the capsule's deployed, and you're in 0 Gs for I think it's 3 or 4 minutes, which is awesome. You get this full rocket experience. You take the flight all the way up. It's kind of like your own rocket launch, except you're not going into orbit, but you're still getting to experience 0 Gs and the entire thing. Whereas on the other side of things, I think Virgin Galactic, it's a much more gradual flight. You still have that rocket launch-esque, but you're lifted from a plane. The takeoff is from a plane. You land like a plane. I guess that's another point of Blue Origin, is you're in a capsule. You're coming back down under parachute. You're still kind of strapped in. It's not what you're necessarily used to, but it's still more so that space, return from space type of experience. Virgin Galactic, you're under the mothership. The mothership takes you up to the right altitude. You're probably in the plane for an hour or so before any rockets ignite. And then you're dropped. The rockets ignite just for a minute or so. I think it's actually very close to a minute. It's like 60 seconds. And once that's done, you have a few minutes of zero G. And instead of, being straight up, like in a capsule, you're kind of flying more like that of a plane that's just going really fast. Although it's still pretty high in terms of the G-forces you experience, it's not necessarily directly related to, or it's not like, exactly like a full-blown vertical rocket launch. And then you also come back down and land like a aircraft. One of the things that I noticed when I was watching the flights that took place the past month or so is that it seems like Virgin Galactic has a much larger space in their cabin. I don't know exactly how large the volumes actually are, but at least when watching some of the videos, I believe the Virgin Galactic flight had 6 people on board, and it seemed like they were all capable of, getting up and moving around. And the Blue Origin flight, I think, is capable of holding 6 people. However, it does not. It just seemed like a little bit more crammed, or everyone was against the windows. But then again, on the other side of things, you also have larger windows in the New Shepard capsule. So, you kind of have this like give or take. Do you want more space to play around in weightlessness, or do you want like this massive window that looks out? So I don't know. I guess the question to yours is the answer to your question is, I might maybe Blue Origin for the full blown rocket experience for the flight itself, but also Virgin Galactic with the space plane and the gradual takeoff. I think it'd be really interesting. Personally, potentially, I would probably lean maybe more towards Blue Origin just because of the windows. I think it'd be pretty incredible to look out the window and just kind of awe in seeing the Earth from space. But at the same point, playing around in zero G, I guess it depends on if it was just me getting a ticket to go for myself, or if it was a bunch of people, kind of having this community going up into space and oh, I put the wrong color piece on. No, I didn't. That's actually the right one. I just forgot to put one here. If it's this community-esque, or if it's just you, because I feel like if it was just you, you'd be going up and looking out the windows and more focused on what you're doing. Whereas if you're going with maybe a bunch of people you knew, having fun and doing backflips and doing all that kind of stuff would also be maybe more of a preference. But I don't know, it'll be weird. I definitely think that in, a couple years or so, there's going to be a lot of these videos of people going up and having a grand old time in zero gravity for a few minutes and then coming back down. Imagine going to space with a flat earther. Yeah, I think it would be a very eye-opening experience. I mean, I kind of just think about, all these, I guess, being on YouTube right now, you just kind of think of all these creators or people that are going to go up and have their own, the spaceflight experience, the Blue Origin experience, the Virgin Galactic experience. Oh, I bought a ticket on Blue Origin's spacecraft. I can't wait to see those videos. Those will be a lot of fun. And it'll get a lot of people interested in space, I think. Because even though, I don't think, probably not in the near future, I don't think everyone's going to have access to space, or even, in a longer term, it'll still be very expensive to take one of those flights, or even to go into orbit. Hopefully it drops in the near future, but as we've seen, the demand to do that is very high right now. Spending multiple millions of dollars, I guess in the case for Blue Origin, $28 million to go on a suborbital flight, that's just insane. So the demand is incredibly high, and there's definitely a lot of people that are willing to pay a lot of money to do it. So I imagine in the near future, it's probably going to stay the same price. But maybe in the further future, it can drop down. But even if there are, a lot of people that go and create these videos and have fun and, get to experience this, it'll be able to share, what space really means to a lot of people, and, how much further we can still go, because these are just suborbital flights that reach 80 to 100 kilometers or so. And when we want to think about going to the moon, where we're going 400,000 kilometers away, it really puts into perspective of, wow, we really need to be going far to be doing some of these things. More towards Virgin because the experience lasts longer, but yes, a rocket is a rocket. Yeah, that's a good point because, if you're with Virgin Galactic, you get in the plane, you take off, you're still under mothership, which would be really cool to experience, and you're in this plane for a couple hours, maybe 2 hours. I don't know exactly how long the flight was for Richard Branson's test. It actually didn't seem like it was 2 hours, but generally I think what they say is it's supposed to take around 2 hours from beginning to the end. So I guess I personally wouldn't be that surprised if it takes 2 hours, but I mean that would be really exciting, to be in the plane for 2 hours or to be in the plane for an hour and a half and finally take off, get the zero-G experience, and then land back down. I don't know. It's fun both ways. I guess since it's a lot of probably very rich people that'll be doing it, there'll probably be plenty of people that are getting both experiences. So that wouldn't surprise me too much. All right, so now it looks like we're putting in something very interesting. Don't know what exactly it is. Looks like the back, maybe the engine block. If I show you here, then there's a connection here, and these go into the hydraulics for the landing pad. So this is very interesting how this is set up here. I want to make sure that I do it right. All right, so those seem to go in pretty well. All right, that one went in. And that one went in. All right, perfect. Okay. Yep, so now we're going to be building the RS-25s. Here's one of them. Here's another one of them. There we go. Look at those RS-25s. And here's the third one. This is the fastest rocket engine producing factory in the world. We just made 3 RS-25s live in a matter of seconds. Oh wait, no, there's still a little bit more I need to add. I think an interesting question, we say, would you rather fly on a Blue Origin New Shepard or Virgin Galactic's Unity? But another interesting question is, if you had the chance, would you rather fly on a Cargo Dragon, or sorry, not Cargo Dragon. I hope you don't want to fly on a Cargo Dragon. Would you rather fly on a Crew Dragon, or would you rather want to fly on a Space Shuttle? I think I'd rather want to fly on a Space Shuttle. I think that would be truly an awesome experience. But it would also be really cool to fly in a Dragon. Just the futuristic component of it, but then the Space Shuttle, has that historical aspect of it. That's actually a very tough question. But I think I would still stick with the Space Shuttle. Actually, Professor Snape, someone mentioned that yesterday, the 3D printed rocket video, and I actually watched that last night. They mentioned it during the other live stream. And I watched it, and it was really interesting. The company is Relativity Space, and I don't know, it'll be really exciting to see how well they develop. I know there was some talk from Scott Manley about, the capability of 3D printing rockets. And eventually, you will fall into some optimal design where you can be able to develop something. But it will be interesting to see, how much they have to develop, how reusable their vehicles are, how well they work in space. It's really this like cutting edge or future development of what's happening with 3D printing rockets. So I'm really excited to see how they develop. There's a lot of, I kind of mentioned this yesterday too, but there's a lot of SpaceX and their success in, reusability has really shown, the aerospace industry that, hey, innovation, there's a lot of ways to be innovative here. And, although it's a lot of risk and, not all these ideas are going to succeed, you can take those risks. And if they pay out, then it can be really useful for the future of spaceflight. Whether it be Starship, or whether it be 3D printing, or whether it be catching rocket engines off of a Vulcan with a parachute or something. There's a lot of concepts that we have to try and we have to see. And if something actually turns out to work really, really well, then we gotta see through it, because any way that we can bring the cost of space down is good. It's still pretty expensive, even today with all the improvements. It's still pretty expensive to send anything into orbit, and the more we can lower that, the more stuff we can send to space, and the more stuff we can send to space, the more instruments we have, and the more instruments we have, the more we learn. And it's just this perpetual greatness of knowledge if we learn more and gain more about it. So yeah, so there's the base, making a lot of progress here. Here's the engines, RS-25s. There's the structure. It's pretty exciting. They're awesome. They're awesome. RS-25, very compact. I've been next to one and visited Cape Canaveral a few years ago. Columbia was at the pad, but I could only see the tip of it. Oh, that's really awesome. Yeah, RS-25s are pretty incredible engines. And they're going to be used on the Space Launch System. So, yeah, it should be exciting. I think I missed a Did You Know? Yes, I did. So here we have another Did You Know in the manual, saying by pumping super cold liquid hydrogen through 1,080 tubes in the nozzle wall before it enters the main combustion chamber, the engine is kept at a cool 50 degrees Fahrenheit or 10 degrees Celsius. Yep, so although it's not really represented too well here, these kind of look like barrels, but the liquid hydrogen, or yes, the liquid hydrogen would be pumped through the nozzle before going into the injector. It would be in here. And this would essentially allow it so that the nozzle would not melt, or it would stay at a cool enough temperature that it wouldn't deform. Yep, it's truly rocket science. It's pretty impressive. All right, so now we're getting into bag number 11. We have another Did You Know? This one says, as regulations require that the stars always face forward as the flag is traveling in the wind, the American flag on the starboard side of Discovery's fuselage flies backwards. So yep, so on aircraft and even some patches, you'll notice that the American flag is backwards, or appears backwards. I don't know how well that will focus. But that is because as the wind essentially blows across the vehicle, so for example, if Space Shuttle was flying forward like this, wind would cause the flag to fly backwards. So that's why the blue is on the right-hand side here. That's just a fun fact. All right, so that just means we have to remember which way to put this one on. Yep, so I guess I could show you again on the side of this. We have the US flag here, which is just on the wing. And on this side, where normally it would launch vertically like this, as the wind is blowing it, the flag would flow downwards, or flow along where it says United States. Yeah, well, you can say that. So if it was flying up, it'd be that way. However, on the other side, we can see that if the shuttle was flying upwards, or towards me, I guess, the flag would be blown backwards, and that's why the blue is on that side. pretty exciting. So yes, the RS-25s are going to be used on the space shuttle, the Space Launch System, or SLS. But unfortunately, there's no plans to reuse them. Therefore, at least I don't think there are any plans to reuse them. Therefore, they will just be made for each launch. So they are still incredible engines. But they will not be reused for the Space Launch System. Or they are being used for the Space Launch System, but from launch to launch, they will not be recovered. I can't remember what we were mentioning before that. Oh, I think we were talking about space shuttle versus flying on a crew dragon or cargo dragon. I keep saying crew dragon. No, it is a crew dragon. Man, I'm getting my words mixed up. Yeah, I think flying on a space shuttle would be pretty remarkable. But also, I mean, from we've seen, you know, all the incredible displays and everything on a crew dragon, that would also be pretty exciting. I think both of them offer really different experiences. It'd be interesting to listen to an interview of, you know, some of the differences between flying on a shuttle, flying on, or even a Soyuz. You know, all three different vehicles. Shuttle being the space plane, Soyuz landing on land, Dragon landing on water. They're probably quite different experiences. Even though we think of all flights to space as kind of being similar because they're rocket launches, you know, there's still a wide variety in what it actually means. You know, and even further, you can think of it as some of these launches, you know, upcoming SLS and going to the moon, like those in themselves will be very exciting. Just to see everything that goes on. So I'm excited to see the SLS launch in hopefully a few months. I think it's planned for November of this year. It'll be interesting to see who launches first, whether it be Starship or the booster, the orbital launch, or SLS. To be quite honest, at this rate, I don't really know which one will launch first. I feel like Starship is definitely, you know, kind of waiting to be launched, but it also has a lot of testing we talked about earlier. But SLS, you know, it's being put together in the vehicle assembly building. It's being stacked. There's still a lot more that it has to go through, but you know, it's just a couple months away. A lot of these projects that people have been waiting, to be quite honest, decades for, you know, SLS about 10 years and James Webb, you know, multiple decades, you know, are kind of coming together. There's so much happening in 2021 in terms of spaceflight that who knows if 2022 will be as exciting, or maybe some of it will be pushed back into 2022 and, you know, we'll still have a lot of that excitement. But we're still working on the aft of this shuttle. I don't know exactly what we're focusing on here. We seem to be putting in some axles, so I don't know if that'll be something that is designed to come off or come apart, or maybe this will be the one of the fins near the back. Not sure. It's definitely a very dense build, very intricate, a lot of small pieces. I guess it has to be. It's supposed to be scale. I think it's a 1 to 70 scale of Space Shuttle Discovery. Just like the Discovery had a lot of pieces, so. Yep, Milky Way, it is hard to beat how amazing space shuttles were. They were pretty impressive vehicles. But I think just with everything, with space exploration, improve upon designs, learn more about it, figure out how, what ways can we extend it, what ways can we? And I think to go back to the moon, there had to be focus on SLS or different programs. So Space Shuttle was able to do a lot. Had over 100 missions between all the vehicles. I think Space Shuttle Discovery actually had the most. Let me check. I think Space Shuttle Discovery had something like 30 some odd missions. Let me see what that says. Space Shuttle Discovery. So Space Shuttle Discovery. Let's see. Yes, it was the most flown space shuttle. It had 39 space missions. The first one being in 1984 and the last one being in 2011. Cumulatively taking over 365 days in space. Space Shuttle Discovery was also the first U.S. spaceship to fly a Russian cosmonaut. That's a fun fact. Pretty exciting. So yeah, Space Shuttle Discovery, one of the most flown, or the most flown space shuttle. Oh, let me open up. Thank you, Rain. Yep, so this is what we're working on, Space Shuttle Discovery. It's starting to look shape. We built all of this today. Yesterday we built Hubble. So, what we've been doing, but still making a lot of progress. Again, thank you everyone for joining. I really appreciate all the comments and questions and suggestions. Had a lot of fun discussions talking about James Webb and moons of Jupiter and Saturn and Europa and Ingenuity, Perseverance. So much fun stuff happening. I feel like I put all these on, but I don't know if I did. I think I did. We'll see. We'll see if I skip something. I think I personally have seen 2 of the space shuttles. Space Shuttle Discovery, I actually saw Space Shuttle Discovery in Virginia in the Air and Space Museum, the Uber-Hazy Museum, which is currently on display, and Space Shuttle Atlantis, which is currently on display, I think, in Kennedy Space Center in the on exhibit there. I've been fortunate to see 2 of them. I did not see one fly though. At least not from the Cape. I guess that was the only place it flew, but I did not go to the Cape to see one fly. Right now we're building kind of this back end of the shuttle, the aft side, kind of building this ramp to go around the engine block. Oops, put that on backwards. There we go. Now we're putting on, so right here, I don't know if you can see it from your perspective, but right here we have all these studs right here, and it looks like we're just putting on a bunch of plates to give some more detail to the back, where there's a flag, and it looks like some places where we'll be able to attach Hubble if we want to put it into the payload bay in the set itself. This is a very cool set. A lot of attention to detail. It also looks like we're going to be very close to finishing another bag here. Let's see, what's a fun mission coming up that we can talk about? So we talked about SLS. We talked about the Ingenuity flight, which just recently happened. I wonder if there's more information about it. Let me actually see. I've been trying to follow pretty closely. Find something. Nope, still, I don't think there's been too many more pictures updated from it. Not for Flight 12, at least. If there have been, then I'll be missing a lot. Nope, I don't think there's been any more pictures uploaded. Let's see. What's another mission that we could talk about? So we are going to be seeing, I guess the next year or so, there's going to be a lot of new. We talked about a little bit about crewed vehicles. We're going to be seeing potentially Starliner later this year, early next year. We're going to be seeing some more. We're going to see Inspiration 4. We're going to be seeing Crew 3. Potentially Crew 4 later next year as well. We're going to see the crew mission from, or the, keep pronouncing it, I'm not sure, Gangarana, that's definitely not how I pronounce it, from ISRO. And we'll be seeing Orion launching on SLS, but there will not be crew on board. So this next year should be really interesting from a human spaceflight perspective. We'll be seeing a lot of vehicles coming about. Those vehicles will definitely be the ones that take us to the moon, the low Earth orbit for different nations. It'll be exciting. I guess in terms of Mars missions though, last year was the big year for Mars missions, because we saw the Tianwen-1 mission launch from China. We saw the, forgetting the name of it. I made a video about it. The Hope mission, the Alamal mission from the United Arab Emirates, UAE, and we saw the Mars 2020 mission, and all 3 arrived at Mars successfully, which is exciting. Now, interestingly enough, this is actually a side note, but talking about TN11, it definitely landed on Mars later than Perseverance. Perseverance has been on Mars since a while now. It's been on Mars since the... oh, did I forget another piece there? I did forget another piece there. It's been on Mars for quite some time. So Perseverance got on Mars in February, although it arrived at Mars after TN11. Whereas TN11, which is China's orbiter and rover combined into one, that their mission arrived in early February. However, they didn't land their rover until later, and that's just due to differences in the design. So it's actually meet the 90 soul limit. So it was only designed to live on Mars for 90 souls, which is very similar in nature to the Mars exploration rovers, Spirit and Opportunity, who are also only designed in air quotes, to live on Mars for 90 souls. Because generally, a lot of these programs are designed to live for so long, but at the end of the day, because of the margin of error and how much room they gave for operation, and maybe how much funding is available for the program, it could be extended. And that's seen for most NASA missions. I mean, the InSight lander, Curiosity even, I believe, Spirit and Opportunity. I'm not sure about Phoenix, I imagine so, but for all of these spacecraft, they usually go beyond their extended lifetime. And that's so far looking like it's going to be the case for TN11, or Mars rover. So that should be exciting. So I already opened the bag, but we're on to bag number 12 now. And we have another question. Did you play the game Surviving Mars? I liked it a lot. I have played it very recently. I actually didn't play a lot when it first came out, but I have played it recently, and it is a lot of fun. But I definitely want to get back into playing it a little bit more. It's really fun to be able to try and create a colony on Mars and manage all those type of things. One of those fun simulation-like games. I really enjoy that kind of style. Yeah, that's a good question. And then Milky Way, but that Orion is supposed to go to the moon and back. Yes. So if you are not aware, the Orion space capsule is what sits on top of the Space Launch System. So the Space Launch System is the giant rocket that NASA is building, or a bunch of contractors through NASA are building. And the Orion capsule is the capsule where the astronauts actually sit in. So that goes on the very top. So the Orion capsule is supposed to take astronauts to orbit around the moon. It does not land on the moon. So if we think about the Apollo era, the Apollo capsule would take astronauts from the moon into orbit and then back. So basically the Orion is kind of like the Apollo capsule. But Apollo had the lander involved with the launch, whereas the SLS does not. So SLS is only launching Orion to orbit around the moon. So Orion can get to the moon, depending on which orbit it wants to go into, and then we'll come back to Earth. So it's basically the main transportation from the Earth to the moon, but not onto the surface. So that's a very good point. Is Orion is supposed to go to the moon and come back, but not necessarily land on the moon. So as an update, we are working on bag 8 now, which is starting to work towards the front or the nose of the vehicle. We're finishing a lot from the aft here. So we did the engines, we did the engine mount, and we have, these pieces are kind of coming off. That's not good. That's not good at all. Let me fix that piece. Push it down harder. There we go. Perfect. So we have the aft here, we have the engine block, we have the RS-25s, we have this right here, which I think if you push releases the landing legs, and we have this part right here, which I imagine is going to hold the rearward vertical stabilizer, or one of the fins that comes up. So yeah, that's exciting. And now we're working on the front, the nose. Oh, actually, we're kind of working on the payload bay again. I think I skipped this though. Let me check. Yes, I did. I definitely skipped this. Yes, so Orion is the crew capsule, which is scheduled to be launched in late November of this year on the SLS. It will not be crewed for this flight, but the first crewed flight is supposed to be Artemis 2, which will take flight I think it's currently scheduled for sometime in 2023. So essentially this first test is to launch around the moon, go out there, send a mannequin on board called Campos, I believe, Moonican Campos, and it's going to record all the radiation and, well, not just radiation, but all the components of flight and see how well everything goes. So it's basically a test launch for the vehicle and the Orion capsule. And then they will learn from all that, see if there's any changes that need to be made, and then start working towards Artemis 2, which will be the first crewed launch back to the moon, or to orbit around the moon, since Apollo 17. So I think, if everything goes as currently scheduled, which means that it will happen in, 2023, then that means it'll be over 50 years since we last sent people to orbit around the moon. So yeah, that'll be a long time. It's a long time coming, but hopefully it'll be exciting. I'm excited for it. And then with the development of Starship and HLS, Lunar Starship will meet Orion in orbit. Depending on what orbit it goes into, it'll meet Orion in space around the moon. Might even be a gateway, depending on what the time frame is. And then they will use HLS, or the Starship, to land the astronauts on the surface of the moon. So it's a big process to get people back there. It'll be exciting. So yeah, we're working on this payload bay. We can see right here. Oops. Put one in the wrong spot. You put one of these there instead. Let's see. Milky Away says, if Jeff lets us. Yes, if hopefully HLS can proceed as normal. I don't know. I think hopefully in the near future, there'll be able to be a second round of either crewed or cargo landings to the moon, and Blue Origin and Dynetics can be involved in that. But we'll just have to see how this whole process goes along with Blue Origin and challenging a lot of the HLS decisions. Nonetheless, I think it'll be very difficult to reach the 2024 timeframe combined between HLS and Artemis, SLS, etc. Because that's only 3 years from now. I mean, 3 years ago was 2018, and 2018 the InSight lander was going to Mars. That kind of just seems like yesterday. 3 years from now, not only are we supposed to send Artemis 1, but also Artemis 2 and Artemis 3. I think that's a very quick time frame. But who knows? You never know what could happen. I mean, if everything goes according to plan and all the tests are successful and there aren't any major design changes needed, then it could be quick. We could have things operating on the moon within a few years and a moon base and all that fun stuff. We're building these side parts of the cargo bay, or the payload bay, for the shuttle. I'm not sure exactly what these pieces are going to be doing. They might, kind of like the ones in the back that I said before, they might be what holds Hubble in, if you want to put it in the actual bay itself, or it might actually hold the top of the bay, if I show you these a little bit closer. Oh, that one doesn't even look like it's fully on, but it is. So yeah. Not quite sure. We'll see. We'll see what they're used for. Another did you know? It says the mid-deck of the orbiter is where much of the crew's equipment is stored. It's here the astronauts change into their spacesuits before exiting the airlock and floating into the payload bay. I imagine it's referring to this area right here. So the astronauts would generally be up here in the nose, and this area right here, the short area between going from the cabin to the payload bay, would be an airlock. So that's where they have to get changed into their spacesuits if they want to go out. Otherwise, they would not be good without spacesuits outside. So they need to put those on and do so in the airlock. Now it looks like we're just kind of building up the payload bay a little bit more. Still using a lot of these smaller plate pieces. Definitely, as I mentioned before, it's a very dense set. A lot of small pieces, very intricate, very detailed. We also have 28 of these tiny pieces. So this one step, you have to put 28 of these tiny pieces on. That's gonna be fun. Rain says, what is your favorite space movie? Ooh, that's a very good question. I'm a big fan of The Martian. I think my YouTube name might be pretty biased towards that. I don't know. I personally love a lot of things that have to do with Mars exploration. Not only just Mars, but also space in general. But I think The Martian does a really interesting job at, kind of giving you a lot of science. I haven't read the book, which I really want to. But it gives you a lot of kind of insight into, these are, real principles in science, or, pretty close to real, and how we can use some of these ideas and, by being smart about it, learning, okay, well, if we tailor something to be one way instead of another, we can get a different result. And that's just how Mark Watley stays alive on Mars. So I think that's a big one. I also am a big fan of Contact and Interstellar, a lot of the popular ones that I think a lot of people say. Just, kind of bringing some of those concepts from astrophysics or, concepts that aren't necessarily something you would think about in every day and apply it to some really interesting storyline. Yeah, probably Martian or one of those. Oh, you watched it recently? I'm guessing The Martian. Yeah, it's a big favorite of mine. I guess Apollo 13 is another really good one. It really goes to show, a lot of challenges that had to be overcome. Even though it's, it's the Hollywood version of it. It's really cool to watch it, know the story. So yep, we're still adding to the payload bay here. Building it up slowly so that we can maintain our satellites or our spacecraft. We're also going to be building a tiny little computer, which is pretty cool. I'll show that off here. There we go. Tiny little computer, some of the knobs and buttons to fly Space Shuttle. Discovery. And this is also the tiny little chair it gives us. No minifigures though. Fell for aliens, alien then aliens. Yeah. Yeah, I'm a big fan of all sorts of science-based movies. Star Wars, Star Trek. They're always really fun. Oops, he's gonna go the other way. Yep, looks like we're building the crew area here, or the nose, where the astronauts would be living for the few days that they were on orbit. Bunch of small technical pieces. I think this is supposed to be the airlock. I guess I can show this in a second here. But here, oh, that's not the right piece. This is, there we go. Yeah. Here, I imagine is what they're predicting the airlock is supposed to be. So going into that circle there, going into this middle region right here, takes you from your nice, safe crew cabin area to the vacuum of space. Or would be right there. Pretty cool. Very interesting design. And again, finished with bag number 12. All right. So I think we're gonna do bag 13, and then that might be the end for today. Looks like we're building the Canada arm. Yeah, so we'll do bag 13, and then we'll probably finish the rest of it off tomorrow. I don't know, oh, I think this might be the top of the payload bay is what we're putting together here. So anyone that might just be tuning in, this is day 2 of building the Lego Space Shuttle Discovery set. Yesterday, we spent about 2.5 hours building Hubble right here. Today, we are on about hour 3.5, or a little bit past that now. Wow, building Space Shuttle. So we made a lot of progress today. Do the fins, payload, part of the nose, and the engine mounts, as well as the RS-25s, and we're putting together the last bag. So this is going to be bag 13, the last one that we do today. Yeah, it's really looking like it's coming together. Very exciting. Seem to be putting more buttons or little pads on here for the crew, so it looks like this might also be a part of the nose or part of the cabin. Yep, and these are also some clear pieces, so I imagine that these are going to be near the front. Professor Snape says, does it come with astronauts? No, the set does not come with minifigures, unfortunately. Or no little people. If it did, they would be probably tiny little, maybe even 1 stud pieces, because this is a 1:70 scale, so, you know, it would have to be pretty small. I think the Saturn V set comes with astronauts. I'm not sure, though. But yeah, I'm pretty sure the Saturn V set comes with astronauts. Or maybe the International Space Station one does. I'm not quite sure. If it did, then I would say it probably should come with, if this set came with astronauts, I would say it probably should come with like 6 or 7, because most of the space shuttle flights had quite a bit of astronauts on board. each flight of a space shuttle was almost like an entire team of people going up to orbit. Just so many crew members that were able. I mean, looking at it now with the Soyuz, they can launch 3, and I don't know how many Crew Dragon can hold, but generally they stick with 4, I think. 3 and 4 seems like a lot even compared to 3. And looking back at some of the really early missions, 3 is a lot compared to just 1 person. But having 7 people, 7 or maybe even 8 people on a launch, it's like an entire team. Bunch of experience. And then for the upcoming moon missions, I think it's supposed to be either 3 or 4 that go, but I'm not quite sure. I think it depends on how many people can actually go to the surface, because that's still a limitation. Having someone in orbit and then also having people go down the surface of the moon. Which kind of raises another interesting point is, when we have our first missions to Mars, whether they're in a starship or whatever vehicle they may be, how many people are actually going to be on these trips? Will it be 3 or 4? Will it be 10, 15? Who knows? Again, something only time will tell. Hello, Mark. Your case for Mars videos helped me so much on a school project. Well, I'm glad they're helpful. I know I really enjoy making a bunch of those kinds of videos, and I've gotten some comments in the before from people saying that they are helpful for projects, but I always love to hear that one of my videos is either used in a classroom or helpful for school projects, because that's one of the main reasons I'm doing it, is to help teach people about what's going on, whether it be on Mars or whether it be spacecraft or upcoming missions or just science in general. It's a lot of fun. It's a lot of fun to learn about it, a lot of fun to write about it, a lot of fun to make videos about it. But I'm glad it's helpful. Yep, so this part that I was saying before, where we're bidding this, right here, this is a window that's going to look from the crew, or from the nose, or from the crewed area, back into the payload bay, which is the other side. So these instruments would be used to control Canadarm or the payload bay in operating anything or spacecraft that need to be deployed. So this is going to go right here, right in between the payload bay and the nose. And now we're putting in some pipes, I guess. Guess that's what it's supposed to be. Whoops. There we go. There we go. Yep, so this is what we just added. Right there, that little mirror on this side where people would be in, habitable area, they can operate the computers. All right, now we're building something. It says the KU band antenna is deployed in orbit and allows the crew of the shuttle to send and receive communications from Earth. So it looks like we are building the antenna. So that's exciting. Oops, put in the wrong color here. This is actually going in the back, so I think this might be what grabs one of the arms, or one of the parts of the spacecraft when it is in the payload bay. You know, a lot of the shuttle missions did a very wonderful job in the development of the International Space Station. You know, this very large cargo area is what really helped in sending these larger modules to be used for parts of the space station. That was a main part of collaboration. Not only to get astronauts up there in a place for astronauts to stay temporarily when things needed to be developed, but also, you know, in general, just sending up parts of the space station for construction. And as most of it was developed by the end of the 2010 or the early 20s or 2000s, I should say, not the 2010s. That was when a lot of the transitioning to ending the shuttle was, because, you know, the prime objective of building the space station was nearly complete. And there have been new modules sent and, you know, test modules and so on and so forth, but, you know, a lot of that main structure is still up there. And probably in the future, you know, going in with the next couple of years where there'll be more vehicles, visiting vehicles, whether it's commercial vehicles or, you know, launching astronauts, it'll be very important to use, or it'll be very important to know, or I guess to have enough space for these visiting vehicles. That was something that someone alluded to earlier, that, you know, with Starliner and some of the challenges with it going to the ISS, you know, just having enough docking ports available will be a challenge if there's a crew dragon or a cargo dragon or a berthing port available for Cygnus. There's a lot that has to be kept in mind in terms of sending all these crewed or cargo missions to the space station. I mean, we could have all the missions available to send them there, but if we don't have enough docking ports on the station, then, you know, just like parking spots, if we don't have enough parking spots, we can't send enough people up there. So, and I don't think anyone's going to want to be parking on the road or just next to the space station and not docked. That would not be good. So either that means building it up more or adding more ports or whatever it means. We'll just have to wait and see. I know there's a lot of interest in sending or building off in terms of having a commercial space station that starts as part of the International Space Station and then eventually is released to form its own thing. But that is also something we'll just have to wait and see develop. Yes, Axiom. Milky Way is exactly right. Axiom is the company that's working on that. A commercial space station. A hotel in space. Not really a hotel. It partially could be used for crewed missions, but also probably be a lot of paying space for scientific instruments and having dedicated space for those instruments. Which also could mean private astronauts and astronauts that are up there specifically just to maintain scientific instruments. But I imagine as long as the International Space Station is operating for the next decade or a couple decades, NASA will probably be a main contributor in providing access to science instruments in orbit. But again, NASA is focusing on, you know, commercializing low Earth orbit and allowing people to grow from that. So who knows? Who knows? Maybe 15 years from now, low Earth orbit will be mostly commercial companies or private companies, and NASA will be moving to the lunar space, cislunar space, and beyond. Should be exciting. So it looks like we are building Canadarm right now, and I kind of figure that from this long stretch of essentially tubes that we're building and can kind of shape into all sorts of directions. So, and on the next page, The shuttle's remote manipulator system, the RMS, was used by astronauts inside to deploy and maneuver cargo in the cargo bay. Guessing what that is referring to. Is this also known as Canadarm? Canadarm? This, I guess, is supposed to sit right here. Oh, now we're building tiny little cameras. Look. Show you the cameras. Or lights. We gotta build 4 of these little ones. A little camera. Or light. Also need to make sure this is the right color. I think it's light gray. Yeah. It's supposed to be light gray. Or maybe more of this reflective gray. Let me see. Yeah, I think it's the reflective one. Yeah, it should be interesting with, you know, as Axiom develops and decides to build a space station in low Earth orbit. Whether people take it as, you know, a hotel or more instruments or more space or whatever it ends up being. It'll be cool to see. So this is 3 of 4 cameras. Then we'll have the last one, which, oh, it goes in the middle here. That one goes, actually, it looks like it goes on the arm, which is pretty interesting. Yeah, looks like it goes on the arm. And this little divot here. Yep, there we go. All right, so now we got to build some of these, the doors for the payload bay. I'm going to build quite a few of these, so we're also going to put quite a few stickers on. Let's see how these work. With that, then we have one of these, another extension here. We flip it over, we want to put 6, a 7, and a 6. So we're going to be putting on these reflective surfaces, which are supposed to act as radiators. So when the space station gets into, or not space station, when the space shuttle gets into orbit, even though it's all painted white, it still will get pretty hot. So these reflective surfaces are used to radiate heat out. Or the radiators take in the heat and radiate it out back into space. So yeah. So again, the space shuttle did not use solar panels, it used fuel cells. It took fuel, the hydrogen and the oxygen, and it put that together to generate energy and also to great water. So that's a difference from other spacecraft which we see, like Dragon and Starliner and this International Space Station, which all use solar panels. Space Shuttle used fuel cells. So there we go. There's that reflective surface. Very bright surface we can see there. That is being used for radiators. Then we have to add a couple more of these stickers. Then we're going to do this whole thing again. This is something that I really appreciate about these stickers, is that you don't have to overlap pieces. So if you wanted to take this apart, even though you have stickers on them, the stickers don't actually overlap between these two large white pieces. So you can easily take pieces apart without having to pull stickers off. I'll show that. You can see that these are two separate stickers here because they're two different pieces. So if, for example, you wanted to build it again, you could take it apart and you wouldn't have to worry about any stickers peeling off. Unless you purposely peel the stickers off, but I don't know why you would want to do that. Alright, and now we put another one of these bigger pieces on. Right here. Another one of these reflective surfaces. We put these on. We have one of these, one of these longer pieces, and plate on the top. And we have one of the panels here. This one looks like it goes right here. We're gonna have to be making quite a few more of these. We can already see how that closes over the top. One major part here. So let's do that one again. So radiators are important because as the sunlight will shine on really anything. In space, unlike here on Earth where we have, if you have a hot stove, for example, and you touch something on the stove, you feel something that's very warm. Heat conducts to you and you feel it. Whereas in space, you aren't really touching much. You are touching the atmosphere sometimes, but generally you aren't really touching much of anything. So you get a lot of your heat from radiation, or radiation that comes from the sun. So that's part of the reason why a lot of spacecraft are either lighter colored or have this very reflective material on them, is because they try as much as they can in the design so that they don't have to, so naturally they don't have to collect a lot of heat. And if they do collect a lot of heat, then they can add radiators, which basically can either actively or passively cool the system. So a passive one would be, designing something that's reflective and will naturally just cause it to be cool. Another way to passively cool your spacecraft is to keep it by spinning. So this is one of the things that Starship, I think, actually wants to do, and a lot of small satellites do, is that they will spin the spacecraft So instead of just one side of it getting really hot, it'll gradually, it'll be hot, and then once it turns away from the sun, the cool side, or the vacuum of space, or being exposed to space, will cool it down. So it kind of does this roll, this constant roll, in order to maintain this cooler temperature. Now, an active way to cool something is kind of like what we talked about before with the engines, where you can run fuel through the system, but instead of using fuel, you can use water, or you can use some other kind of coolant, like what's used for refrigerant. And in that case, what can happen is you can run this cool liquid through your vehicle, starting on the hot side. It would get warmer, collect the heat, and then it'll go to the cool side, and it'll irradiate the heat, or it'll basically transfer the heat from the hot side to the cool side. And that's really important, because if you do that, then you can keep your spacecraft cool, and you won't run into problems with things getting too hot in space. And the reason why that's important is because if things get too hot, then your electronics and everything will start to malfunction, and that's not good. So yeah, that's how a lot of these spacecraft stay cool. A big challenge is controlling the temperature of them. So, a major part. Whereas if you're on a planet, for example, if you're on Mars, then since you're in an atmosphere, a lot of the temperature comes from the temperature of the atmosphere. And since Mars is pretty cool, missions like Perseverance don't have to worry about what happens when it gets really hot, because it doesn't get that hot. Instead, it just is almost perpetually cool. Except for when it gets too cool, then you have to use computers or electricity to generate heaters and to heat everything up. So, space is hard, because you have anything if it's too cold, you got to use a heater. If it's too hot, you got to figure out how to get rid of that heat. There aren't a lot of places in our solar system where it's easy to just send something. Earth is really the oasis. Earth is the best place for all this stuff. Which is why everything seems to work well here on Earth. Rain says, do you think you'll get more space Legos and stream them? I would like to. That'd be fun. I know there have been some people that have also commented saying that they would like to see some live launches. I think it would be interesting to see, or I think it'd be interesting to keep doing them. I know that I'm a student, so currently my semester hasn't started, but as things progress, or as things pick up, I think time availability really becomes something. But definitely, if people are interested in, and if people are interested in seeing live streams or doing Q&As or so on and so forth, I'd definitely be interested in doing more of these. I know there's a space shuttle set, or this is the space shuttle set, but I know there's the Saturn V set and the moon landing set and all that, so it'd be really fun. Hi Shane, yeah, so I currently am in graduate school for aerospace engineering. I go to school, I'm studying a bunch of space stuff. So I'm really interested in space stuff, so I hope I'd be doing it, but I'm more interested on like the engineering side and the design of spacecraft and vehicles and, navigating spacecraft. So here we're still adding all the stickers. I don't know how well you can see, but we're adding more stickers for the radiators for the inside of the payload bay. Oh, you're starting your first year of aerospace engineering? That's awesome. That's really exciting. Where are you starting it at? Or I guess I should also ask, what company do you want to work for? Do you want to work for SpaceX? Do you want to maybe go to NASA? Do you want to do Blue Origin? Do you want to do... I feel like a lot of people with a lot of the news from Blue Origin might not want to do Blue Origin right now, but I know there's a lot of really great people there. You want to go to Electron? Not Electron. Do you want to go to... I always think Electron. Rocket Lab, or you international? Do you want to go to ESA or ISRO or Roscosmos? There's so much. Or I think New Zealand recently has a space space agency. Definitely SpaceX, yeah. I think that's a very popular choice. Definitely for what they're doing in Boca Chica right now. That's it's very impressive. University of Minnesota, Twin Cities. So that's awesome. Well, if you're starting your freshman year, and I don't know if you've started her yet, but best of luck. It's a lot of fun. Engineering can be difficult to someone that's currently studying it, but it's also a lot of fun. It's cool to learn about all the sorts of things and how spacecraft work and how aircraft work and how it all plays a role in everything. SpaceX is the frat boy of aerospace companies. Nah, I think SpaceX is a really exciting place for a lot of different disciplines, especially if you're working on launch vehicles. I mean, that's right now they're doing an excellent job at producing reusable vehicles. It's definitely changing the industry up a lot. Yeah, but in terms of developing, for example, developing missions to Mars, Lockheed Martin is a major company sending missions to Mars. Lockheed Martin, I believe, has created the spacecraft bus for almost every, cruise stage that's gone to Mars for JPL since over the last, I don't want to, maybe 5 or 6 Mars missions, maybe even more than that. They have a very large legacy. So, a lot of these even bigger aerospace companies play a big role in sending spacecraft throughout our solar system. And SpaceX, even though they're relatively young compared to some of these bigger aerospace companies, they too have a lot to go for. And ULA, they're one of the prime launch providers for Mars missions, looking at Curiosity, looking at Perseverance, potentially even coming up, who knows? Milky Way says, I think I would go to SpaceX to sweep floors. I don't think they use IBM Z/OS mainframes. It would be fun. I mean, even, really being almost anything. I know there's been some job postings for SpaceX for baristas or, for chefs or whatnot to be on site at Boca Chica. I think just being in the vicinity of everything that's going on there would be pretty remarkable, no matter what you're doing. Because just like any company, I think space exploration generally, even though a vast majority of design, or a lot of design, I shouldn't say vast majority, but a lot of design goes into the science and technology and the engineering of the actual design of the spacecraft, but there are so many more people that are involved in spacecraft design and in communicating what's going on to various projects, whether it be marketing, whether it be finances, whether it be management. Every single one of these projects has a vast amount of involvement from a wide range of studies, and it's all required for this stuff to happen. None of scientific exploration, most of NASA would probably not be as well funded today as it would be if, well, I say as well funded, but as fun as it is currently, if they didn't have as well as a public relations and if people weren't as fascinated in space. I mean, if there wasn't Lego space shuttle sets, then I wouldn't even be doing this right now. So it really goes to show that, getting involved and having all this wide variety of people working on these projects can really help in making these missions and future missions possible. One of the coolest job postings at SpaceX is Launch and Catch Tower Engineer. Yep, I think that's probably one of the only places in the world where you could have a title like that. But that's pretty awesome. Who knows, Shane? Maybe that'll be you one day working as a Launch and Catch Tower Engineer. I don't know, I guess if you're doing aerospace engineering, you might be doing more of the vehicle, but that's pretty awesome. So another fun fact, this will probably be the last one today since we're finishing up this bag, but it says the 60 feet long payload bay doors are always open to activate radiators for cooling the shuttle after it has reached orbit. I guess it's been listening to me. The manual was listening to me. Yep, so once it reaches orbit, you would see space shuttle close like this as it's flying. I guess probably should have put some more pieces on first. But when it would fly through the atmosphere, it'd be closed like this, and then once it reached orbit, even if it wasn't deploying the payload right away, it would open them up, because as they would stay in space, whether it be the white side of the shuttle or the dark side for the thermal protection system, the sun's going to cause it to get really warm. Therefore, they would open this up and allow heat to radiate out of these radiators. And that's the stickers we just put on. Speaking of which, let's add these to here. Let's add these to what I believe is going to be the top. Yep. On the top here. And we can close that. We can put this on here. Nope, those don't go there. These go back here. Imagine will also be some kind of fin. This goes right here. These rounding out the top of the payload bay. Wow, we did a lot today. We got most of the shuttle done, which is pretty exciting. And then we put stickers 5 on both sides. Back corners, let me go ahead and put one on here. This back corner. Here we go. And one on this side. The NASA worm logo is the sticker I'm putting on. That one. Number 5. Another NASA worm logo, so these are going on the sides here. Put those on. We already put these pieces on earlier, but that's not a sticker. And this one we just put on as well. I don't know if you can see that. Oh, yep, right there. Then that looks like the end of this one. We do have 2 pieces though that are not used in a similar color, which is slightly concerning because maybe that means that we put on a wrong color somewhere. Let me check, just double check really quick. Nope, it looks like we have the right ones. Yep, it looks like we have the right ones. All right, these might have just been left over from before. All right, so I think that's going to be the last bag for today. I will probably finish this up tomorrow pretty quickly, doing bags 14, 15, 16, 17. So today we got to page 238. We started at page 70. So we did 168 pages today, I think. Yes, 168 pages. So we did quite a lot. Before, I guess starting today, if you go back from the beginning of the live stream, we only had this done. So we had Hubble done today, or we did Hubble yesterday. So pretty awesome. And we also made this yesterday, the Space Shuttle Discovery sign, the NASA and ESA Hubble Space Telescope sign, and we also made this stand yesterday. So today is all this. We were able to do this over the course of just under, looks like 4 hours and 15 minutes or so, which is pretty impressive. Well, that's awesome. And we were able to talk about a lot of fun things. James Webb Space Telescope. We were able to talk about Ingenuity. We were able to talk about a lot of these Mars missions that are going on, Perseverance, Starship, SLS, HLS, Starliner, crewed missions, and even looking back at Shuttle and some of it. So pretty exciting. Again, thank you everyone for sticking for the live stream. I think this will be the end, so if there's any last questions, I'll give it a minute to roll in. But I really appreciate everyone coming out and listening. This is the second live stream I've ever done, so still a learning progress, but it's been a lot of fun. And I'll probably be finishing up these last few bags tomorrow. So yeah, thank you everybody. Hope to see you in the next one.